bangunan yang dikenali sebagai fabric ducting mendukung objektif dasar teknologi hijau negara kerana mampu mengurangkan kadar penggunaan tenaga selain dapat memelihara suhu alam sekitar. Baru memasuki pasaran Malaysia 5 tahun lepas, sistem ini dilihat pilihan terbaik untuk digunakan kerana bertindak sebagai dewi fungsi iaitu saluran udara bekalan untuk pemindahan udara dan juga pengedar udara.
Sistem fabric ducting di Malaysia ni lebih kurang mungkin dah lebih 5 tahun di Malaysia. Kita sendiri pun dah lebih 4 tahun di Malaysia. And then sistem ini lebih sesuai kepada ruangan yang luas, yang besar. Antara kalau semua orang dah perasan, kebanyakan sistem fabric ducting ini kita pasang di masjid. Di masjid-masjid, di dewan-dewan besar, di mana masjid dan dewan besar ni terlalu banyak pembaziran tenaga elektrik, pembaziran aircon. So kita rasa terpanggil untuk membantu lebih ramai lagi rakyat Malaysia untuk jimat tenaga berkenaan, especially-nya berkenaan dengan sistem penyamaan udara lah, yang kita agak terkebelakang sedikit berbanding negara-negara Eropah yang lain.
Masih lagi memerlukan penyaman udara, namun hanya menggunakan separuh kuasa kuda daripada biasa. Ia dapat membantu pemilik bangunan menurunkan suhu dalam premis dengan kos yang minimum. Ini kerana sistem penyaman udara biasa sukar mengagikan udara sejuk secara sekata, menyebabkan pembaziran tenaga dan bil elektrik kerana memfokuskan penyejukan pada satu ruangan sahaja. Baru-baru ini kami diberi peluang melihat penggunaan sistem fabric ducting ini di dalam sebuah bangunan pejabat yang terletak di Menara IH, Jalan Sultan Ismail, Kuala Lumpur. Jelas, selain memberi suasana yang kondusif kepada para pekerja, ia turut memberi impak penggunaan ruang yang lebih luas dan terang.
Macam konsep yang saya buat kat sini dia lebih kepada colour putih. So saya tonjolkan fabric ducting salah satu sebab dia punya new teknologi. So dekat projek ni memang kita nak tonjolkan fabric ducting punya produk.
Teknologi yang berasal dari Republik Czech ini telah digunakan secara meluas di Eropah dan kini ia semakin mendapat tempat dalam pasaran Malaysia kerana bukan sahaja dapat menjimatkan daripada segi kos, namun pemasangan dan penyelenggaraannya juga tidak begitu sukar untuk dikendalikan.
Kita dah pakai ni dah lebih kurang setahun lebih kita pindah ke sini. So salah satu sebab kita pilih ducting system ni sebab kita nak nampakkan kawasan ni luas sikit. Jadi kalau kita pakai normal ducting ni dia ceiling ni ke bawah. Jadi kita tak akan nampak dia punya environment tu lah, ambient tu kurang nanti lah. So itu yang kita pilih ducting system ni. Itu satu. Lepas tu macam kita di Perintaian Resort ni kita memang titik beratkan tentang environment. So salah satu sebab yang saya pilih ni senang kita nak cuci. Kalau kita nak buat maintenance ke apa senang. Sebab kalau yang ducting biasa tu payah sikit lah kita kena masuk ke dalam apa semua. Yang ni kita cuma buka dan kita hantar cuci je. Dan dia punya level of coolness tu kita nak control pun senang. Compare dengan yang ducting system tu lah, yang normal ducting system lah. Dari segi elektrik memang jimat banyak. Sebab selepas kita pindah ke sini, dulu kita bayar elektrik, kalau compare dengan sekarang ni, saya tengok kita dah jimat almost 60%.
Ternyata kini adalah masa yang tepat untuk pemilik bangunan di negara kita bertukar daripada sistem penyejukan konvensional kepada sistem berteknologi hijau ini kerana memberi banyak faedah untuk jangka masa panjang.
Selamat pagi Malaysia.
Di Malaysia, penyaman udara merupakan sebuah keperluan kerana keadaan cuaca yang beriklim tropika. Rumah atau pejabat yang tanpa penyaman udara boleh menjadi tempat yang sangat tidak menyenangkan untuk didiami. Walaupun kita boleh mengawal suhu bilik dengan penghawa dingin, kita tidak boleh menggunakannya secara sembrono. Semua pun tahu ianya boleh membuat bil elektrik anda melambung tinggi. Oleh kerana terdapat banyak jenama penghawa dingin di pasaran, setiap satunya mungkin menggunakan teknologi berbeza atau mod lain bagi setiap model dan unit.
Dengan teknologi sekarang, semua brand lebih kurang sama. Okey, apa yang perlu dilihat adalah pertama, bajet seseorang itu, kedua, dia punya efisiensi, okey, dan ketiga, untuk aplikasi apa. Sebab kalau kita memilih penyawa dingin yang silap, okey, tidak akan lebih membajakan lagi teknologi. Jadi latar belakang untuk menstudikan apa sistem yang harus dipakai itu lebih penting daripada brand.
Salah satu inovasi dalam penyaman udara telah digunakan oleh Prihoda untuk membantu pemilik bangunan atau rumah menurunkan suhu dengan kos yang paling minimum. Ini kerana sistem penyaman udara biasa sukar mengagihkan udara sejuk secara sekata menyebabkan pembaziran tenaga dan bil elektrik. Dengan menggunakan Prihoda Fabric Ducting, udara sejuk dari penyaman udara dapat diagihkan secara efisien dan menjimatkan bil elektrik. Pengguna juga akan berasa benar-benar nyaman dan selesa apabila menikmati fungsi sebenar penyaman udara.
Bila kita cerita pasal teknologi terkini penyaman udara, antaranya fabric ducting lah, apa yang kita bawa ni daripada Czech Republic, di mana Prihoda merupakan antara pengeluar terbesar di Malaysia untuk fabric ducting, di mana ia mampu menjimatkan mungkin sehingga 50%. Sehingga kan ada satu projek di Menara Kuala Lumpur, Menara KH di level 26 dengan menggunakan sistem terbaru penyaman udara fabric ducting, bil penggunaan elektrik dapat dijimatkan sehingga 60%, di mana bil dia sebelum ni sebanyak RM12,000 setiap bulan dia kena bayar satu level, satu floor. Sekarang bilnya hanya RM5,000 sebulan, sebanyak RM7,000 dijimat bil menggunakan sistem fabric ducting. So tu di antara teknologi penyaman udara yang terkini yang ada di pasaran. Di sini saya rasa macam kita nak share macam kesedaran berkenaan dengan pemasangan aircon yang betul mengikut certain standard bagi memastikan kos yang kita keluarkan untuk memasang penyaman udara tu biar dapat apa yang kita pasang. Selalunya yang kita lihat ikut pengalaman kita selama beberapa tahun dalam bidang penyaman udara ni, aircon yang kita pasang tak dapat horsepower yang sepatutnya akibat pemasangan yang tidak betul. So kita harapkan benda ni dapat diperbaiki pada masa yang akan datang.
Selain itu, unit penyaman udara perlu diservis sekurang-kurangnya sekali setahun. Menyelenggara penyaman udara mempunyai beberapa faedah. Ia memastikan udara bersih, menjimatkan elektrik dan memanjangkan jangka hayat penyaman udara itu.
Kita sekarang keluar ada baru gas itu untuk aircon. Untuk penguasaan tinggi ini ialah ada R32, ada hydrocarbon. Ini akan kurangkan rosakan kita punya bumi. Kita akan reduce the global warming index. So pada masa yang akan datang, aircon masih penting untuk kita semua orang, tapi kita punya mudah akan inovatif to save energy and to protect our country and our kita punya bumi ya. Okay.
Satu perkara yang perlu anda pertimbangkan adalah saiz bilik atau ruangan. Mengetahui bilangan BTU yang diperlukan setiap kaki persegi adalah penting dalam memilih kapasiti penyejukan penyaman udara yang sesuai untuk menyejukkan rumah anda dengan cekap dan berkesan.
Selamat pagi Malaysia.
Okey, dah bersukan tadi. Kita
saya memang senang, cepat. Untuk saya cepat tau, tak ada masalah. Biasanya kalau pakai pakai nanti dia ada kan, dia ada Malaysia menggunakan finishing dia tak paling kemas sekali kan, dalam kompresor condensation lah, condensation tadi free condensation juga memang dah betul. Itu dia memang cepat kan. Install dia tak enak. Yang potong nanti kan. Biasanya kalau you pergi lama-lama everyday, biasanya untuk 6 bulan pertama tu okey lagi. Bila dengan kombinasi layar tinggi, dia akan nampak maksimum foto. Tak pilih. Ini kita tak nampak. Saya tengok memang maintenance tu boleh kata free lah. Maintenance. Adalah untuk pengalaman sebelum ni di UNW kita pakai GI tak? So kita pakai chili. Ada rumah chili. Ada station. Bila kita kontrol dekat berat di chili kita buka baru. Makan betul. Kita testing 24 jam. Kita jalan tu 24 jam. Dah chili dah kotak. Warna dia dah berubah. Apa baru saya buat apa-apa kapan sampai testing. Sebab ke yalah tukar sekali kita kena setting balik sekali ah. Tium balik tak semua. Ini tanpa tium pun saya propose juga dia punya recommend lah. Saya pakai lah. Sebab tu kan, sebab kita konsenter ni kerja semua nak push sebab aku nak kualiti bagus, kualiti baik, so better pakai lah kan. Betul lah apa ni, dari pakai BCI kan. Nama apa tadi? Tujuan daripada dari bisnes. Bisnes so apa? Lan? Saya Zulkifli dari Mega Jati Consultant. Ya, Mega Jati Consultant. Mega Jati. Apa cadangan abang? Apa recommendation untuk satu lain? Satu lain? Saya memang recommend lah. Sebab saya tengok kalau yang lama di sistem, boleh tengok sekarang gayut-gayut ada kumpulan tu kan. Lalu boleh tengok sini. Kalau boleh tengok di sini memang tuan dia sampai dan boleh dibutuh kan. Apa port ke apa pakai, apa jenis dah pakai, dia pakai tulisan logo sendiri kan. Banyak je yang lagipun saya tengok macam memang senang untuk servis lah. Kalau nak servis lah, kalau foto saya tengok itu hari sebelum ni ada foto skill tuan just selak saja sebab masa tu kita check clearing kan, ada sign ini, ada saya nampak kita bagi wang tak dengan kain basah. Okey lah, tadi itu saja. Okey, terima kasih.
Okay, hai, Assalamualaikum. Saya Faiz.
Assalamualaikum.
Assalamualaikum, saya Zahid.
Hai, Assalamualaikum. Saya Amy, Sales Engineer dari
VRF Malaysia Berhad. Pekerjaan syarikat kami adalah membantu
Building owner,
konsultan mekanikal dan juga kontraktor
Untuk mengelakkan solar ducting
yang tidak memasang sistem ducting secara betul.
mengakibatkan sistem aircon terpaksa di oversize
sehingga menyebabkan pemilik bangunan terpaksa menanggung kos yang tidak sepatutnya.
apabila ini berlaku, kontraktor mungkin tidak dibayar.
Dan konsultan juga mungkin akan dibagi hamba.
akibat daripada sistem penyaman udara yang tidak efisien.
Dengan Prihoda Fabric Ducting,
Proses design menjadi lebih mudah,
Pemasangan lebih cepat
tidak perlu ramai manpower
Tidak perlu lagi membuat kerja-kerja balancing.
dan menyebabkan kos tambahan dapat diselamatkan.
Kini kami mempunyai khidmat proposal secara percuma.
Assalamualaikum dan selamat pagi semua pada yang join kita pada hari ini. Terlebih dahulu, saya Mazlan Abu Bakar, wakil daripada Prihoda Malaysia Berhad. Kami ingin mengucapkan ribuan terima kasih pada yang join pada pagi ini. Okay, so sebelum tu, so hari ini kita akan kita menjemput wakil daripada IMZ, Mitsubishi Heavy Industry, okay, Mr. KK Pang. Beliau merupakan General Manager di IMZ Industry, okay. Okey, sedikit saya berkongsi berkenaan dengan latar belakang Mr. Pang. So beliau mendapat master degree in manufacturing system engineering from Queen University of Belfast, United Kingdom. Beliau juga merupakan professional engineer. Okay, mungkin dia dah ada IR ni minta maaf Mr. Pang, kita tak letak IR okay, beliau merupakan pemegang IR okay. Dan beliau juga telah lama bekerja di Mitsubishi so banyak pengalaman beliau yang kita boleh belajar untuk hari ini. Okay. And then berkenaan dengan topik hari ini, beliau akan berkongsi berkenaan dengan air or water cool VRF system introduction, installation and maintenance. So siapa-siapa yang ada banyak soalan ataupun ada yang tak faham lagi berkenaan dengan VRF, variable refrigerant flow, boleh bertanya soalan dengan beliau nanti. Okay. And then okay. Sebelum kita bermula, mungkin tuan-tuan dalam ni boleh komen dulu, kita nak tengok daripada mana so ambil masa sikit, kita berkenalan sikit kita nak tengok kita punya audio ni. Tuan-tuan boleh letakkan nama, syarikat dan daripada negeri mana sekarang boleh try komen, nak tengok boleh try komen. So sebelum kita start ni, sebelum kita penceramah kita jemput penceramah kita, tuan-tuan minta untuk type dengan chat tu, tulis nama, syarikat dan daripada negeri mana. Okey. Cuba type sikit, saya nak tengok sebab kita ada hadiah hari ni hari ni kita ada hadiah. So ada admin boleh tunjuk hadiah. Ni. So hari ni kita ada free gift free gift daripada special daripada IMZ ni. Mahal ni. Saya cek tengok harga dekat 200 pun ada, 100 lebih pada so kita ada bagi hadiah kita akan bagi hadiah ni kepada pemenang yang bertuah. Nanti Mr. Pang akan bagi soalan soalan, standby elok, belajar elok okey. So sini saya nak baca sikit siapa kita punya idea ni. Assalamualaikum Cik Salmiah Muhammad Saleh. Assalamualaikum, good morning. Okey, Nurain Alang tak nampak skrin. Yang lain saya nampak ni. Okey. Nur Hidayah Nazirah CRCC from Shah Alam. Selamat datang Nur Hidayah. Siapa lagi ni? Murali Cheng Guan, Melaka. Mr. Murali, welcome Mr. Murali. Rajin dia join, saya last time dia ada join juga. Alexander Boniface, College Vocational Matang, Sarawak. Orang Sarawak pun ada. Selamat datang orang Sarawak. Farid, selamat sejahtera. Saya Farid dari ILP Mersing. Mahathir, bagi lebih. Mahathir, daripada Cik Mahathir ni, daripada UiTM ni, selalu join kita punya kelas ni. Rajin belajar ni Tuan Mahathir ni. IR saya rasa ni, IR Mahathir silap saya lah. Shi Kian Wen, UTHM Johor, orang UTHM Johor pun ada. Kong Cheng Guan Ekon, Melaka juga, banyak juga Cheng Guan ni. Muhammad Izrid, SBSC Expert, Terengganu, selamat datang Muhammad Izrid. Akil, ANZ Dynamic, Shah Alam Seksyen 7. 7 orang, ramai ni. ANZ Dynamic 7 orang, selamat datang. Boleh belajar boleh nanti nak tanya pasal VRV installation semua boleh tanya Mr. Pang beliau merupakan pakar dalam bidang VRV dah lama VRV daripada mula start masuk ke Malaysia sampai sekarang so dah lama lah beliau ada pengalaman Mr. Nigel Wong, welcome. Muhammad Syafiq, Bos Berhali, Eddie, Mr. Eddie, Siti Aisyah, MMSB Consult Selangor. MMSB Consultant Mega Jati ke? Saya tak sure ni. Afiq, selamat pagi. Nora Zizi, College Community Batu Pahat. Lecturer pun ada ni, ramai ni. Fauzi, Arub, Juru Perunding, Shah Alam. Selamat datang Cik Muhammad Fauzi Nayan. Farizul Hamidi, UTHM. Joseph Anak Minyol, daripada KV Matang. Ko Han Seng, AirTech Solution Sabah. Good morning. Chan Tek Lun, Yuzwan Zainal, Afiq, ADAE Kemaman. Salam Akmir, Terengganu. Salam Amir Hakimin dari Terengganu. Mr. Nigel Wong dari Perunding Webco Selangor. Selamat datang Mr. Nigel. Syahira Nasmi Engineers Senam Rehat dari Ampang Selangor. Selamat datang Cik Syahira. Francis Eng, Kejuruteraan Rafako Selangor. Welcome Mr. Perancis. Ramai yang kita hari ni yang daftar kita hari ni almost dekat 500 orang antara pendaftaran yang paling ramai setakat ni Alhamdulillah ramai yang minat nak dengar daripada Mr. Pang ni Konsortium Bumi AR Dominic Bernard Nanang Christopher Dawei ramai ni. Konsortium Bumi Consultant SP Sarawak orang Sarawak Sporting ni ramai ni. Chan Tek Lun Perunding CJN, welcome Mr. Chan. Assalamualaikum, salam dari Zuhairi dari PPUKM Ceras. Orang UKM pun ada. Andrew Angah, ramai ni. Saya nak baca habis ke ni. David Perunding Dynatek Kuching, Muhammad Ashraf. Muhammad Ashraf Mega Jati Konsak, selamat datang. Muhammad Aceh Ashraf. Selamat pagi Muhammad Hanafi. Aras Padu, Semrat Johor. Yuzwan Zainal UniKM. Ya, IR tu. Siapa tu IR tu? Mungkin Cik Mahathir kot ataupun Mr. Pang ni IR ni. Semua hebat-hebat professional engineer. Kelvin, Khairul Ashraf, Prudent Air. Ini supplier ni. Supplier apa tu? Grill kan? Prudent Air, Azri Kowam. Nurul Azira UTHM, ABD UTM Shah Alam. Ni engineer UiTM pun ada ni bersama-sama kita hari ni ramai ni. Engineer ada, consultant ada, kontraktor ada, semua kita ada kita kumpul dalam satu platform untuk kita belajar Fandi Wisma LKIM Puchong. Selamat datang Lembaga Kemajuan Ikan Puchong. College Kedah Nasrul MCIP Terengganu. Samsul Tungkus Lumus Samsul Tungkus Lumus. Selamat datang Cik Samsul. Sekejap saya nak tengok lagi komen ni. Sekarang orang suka kita baca nama dia Ibrahim Abu Bakar, MBK Solution. Nigel Kong, JKA Sabah pun ada. Orang JKA Sabah. Grace Gun Salam, JKA Sabah. Selamat datang. JKA Sabah pun ada. Wakil pada JKA pun ada. Okey, Salmian 29 pelajar College Community Hulu Langat. Selamat datang. Ramai student ni. Student pun kena belajar teknologi terkini, semua kena belajar. Nanti kerja senang Afiq mana ni? Zaflo. Ini Zaflo ni, Cik Zul Husni punya ni anak buah ni. Dan Chong, Etika Consult Sabah, AR Chasli, KWA Consult Semberhad, Ashrafiyah. Banyak ni saya nak sebut nama ni. Suhan Nizam Sulaiman, JKA Kesedar. Suhan Nizam pun ada. Mr. Wong, Yong, Air Conditioning Seremban, Pang Expert. Pang Expert macam nak belajar. AB Ibrahim. Saiful, JPS Sabah. Jurutera Perunding Kuasa Tenaga. Khairil Effendi, Encik Effendi pun rajin join ni. Robert Ho, Prudent Air juga. Nanti kita boleh jemput. Ni ramai Prudent Air ni. Nanti Prudent Air boleh contact admin kita. Mungkin nanti next time boleh sharing berkenaan dengan grill diffuser pun boleh juga. Tak ada masalah Boleh contact kita punya admin. Nanti next time boleh bagi talk pula. Ramai nak dengar daripada expert-expert IQ Assessor. Okay. Nak belajar Cik Salina Hang Jebat. Nak belajar VRF boleh-boleh. Okay, Zulaiman daripada ARS Padu Konsortium Johor. Zulaiman, selamat datang Cik Zulaiman. Tan YC, KWA Consult. Nicole, Rentak Juara Sabah. Okay, dia dah habis. Hazim Mustafa, Christian Engineering. Okay, Cik Nazamah. Okay, alright, saya dah bacakan semua. Jangan kecil hati mana yang saya tak baca tu. Okay, nanti boleh stay tune. Okay. So saya tengok sini ada yang menconteng skrin ni. So apa ni conteng skrin? Boleh padam tak admin Kalau tak boleh padam, minta siapa yang tertekan tu kat skrin tu ada boleh tolong padamkan Nanti dia mengganggu slide kita. Ada line merah kat tengah ni. Okey. Okey, sebelum kita start, pertama sekali kita mohon tuan-tuan kalau nak buka kamera pun boleh buka lah. Okey. Keduanya kalau boleh mutekan mic, takut mengganggu. Okey. Kita mungkin akan kumpulkan soalan pada penghujung sesi dengan Mr. Pang ni. Okey. And then Mr. Pang pun akan bertanya beberapa soalan nanti untuk diberikan hadiah ni, 3 lucky winner ni. Okey. Hadiah yang mungkin bernilai 100 ke 200 ringgit. Saya pun tak tahu berapa yang dia hadiah ni nilainya. Ada 3 pieces ni. Sheaffer pen ni. Eksklusif daripada Mitsubishi ni. Okay. So tanpa melengahkan masa lagi, boleh sepulang pada Mr. Pang nak present English boleh, nak present bahasa Melayu boleh, kita tak apa, tak ada masalah. Yang penting kita sampai ilmu tu boleh faham So mana-mana language pun kita boleh gunalah. Okay. Ini siapa yang komen tadi? Can I speak? Okay, can I speak in English? Rosel Tribunal. Kan? Boleh. Nak cakap English boleh, nak cakap bahasa Melayu boleh, kita boleh faham. Tak ada masalah.
Okay, so macam mana penceramah kita, Mr. Pang? Sudah on air
Yes,
ke, Mr. Pang?
Pang sini.
Okay.
Everybody, good morning.
Good morning. So tanpa melengahkan masa, Mr. Pang, saya
Yes.
pass floor to you lah. It's up to
Okay,
you,
thank
nak
you very
present
much.
English ke, nak present bahasa Melayu ke, jangan bahasa lain tu dah lah. Bahasa Mandarin kita tak faham lah.
No issue. Maybe I'm Malaysian, I campur aduk, okay?
Tak apa. Boleh. Campur-campur, rojak pun tak apa. Yang penting kita
English
faham saja.
Okay.
Boleh. Okay, Mr. Pang, go on.
Okay, let me just share my screen. Give me a minute. Host disabled. Okay. How am I going to share the screen? I click the screen. Okay.
Wait.
Now.
Host, please.
Yes.
Please. Wait.
Okay.
For admin to.
Give me a minute.
Okay.
Can everybody see my screen?
Yes. Can see clearly.
Can see, yeah?
Yes.
Okay.
Yes.
Good morning, everybody. First of all, thank you very much, especially Prihoda, to give us a chance, a platform for us to share the information, especially on VRF system. Okay, to all of you. Today, basically, I would like to introduce to you air-cooled VRF, water-cooled VRF. The more important thing is basically installation, operation, and maintenance. Especially when I get the feedback from most of you're saying that actually maintenance are more interested on maintenance. Before I want to talk about maintenance, I would like to share with you, this is the framework you should actually focus into. Do it right at the first place. That means from the installation side, actually, when you do it right, actually the following days, operation and maintenance will become easy. So this is something that I will share with you, and with some pictures proven, and pictures tell 1,000 words, then you can convince yourself. If it's not, then you can try it yourself, okay? So basically, this is some information I would like to share. Okay, before that, let me just take 1 or 2 minutes, just introduce my company. IMZ, actually a sole distributor in Malaysia since year 2000. IMZ established in 1998, okay? And we purely focus on VRF system, okay? I believe right now, this market, everybody know about VRF. 10 years, 20 years ago, when you talk about VRF, actually, not many people know about it, okay? Bear in mind with me, to those who know VRF, basically, just bear in mind with me. To those basically do not know, maybe just take this opportunity to know more, a little bit more deeper, because the purpose for me to actually share with you is I have an intention for you all to go deeper rather than on the surface. People talk about VRV or people talk about VRF, just VRF, tapi kebanyakan tidak mendalam. I would like to try to bring you further in so that you have a better understanding why you need to go, why this project would like to go for this VRF. Okay, so generally, my company from few people grew up to about roughly now 50 people. Then we have all the branches in a different stage. This is actually, we have Penang branch, we have Selangor as our HQ, Puchong side. We have Johor, Kuching, Sarawak, and Sabah. Okay, so today's outline, I would like to share with you VRF. Okay, I believe a lot of people know about VRF. Okay. Then I'm talking about water-cooled, air-cooled, okay, VRF. Okay. Then I'm going to share with you the range and features on that. Okay. Then the benefit of using that, and the system installation. Then we come into the operation and maintenance. Okay. So along the line, if you have question, maybe you can just type in later on. Actually, I think Prihoda side will help out actually to fit the question to me. Okay, so first of all, actually VRF. When you talk about this VRF, VRF stands for variable refrigerant flow. Okay, question number one posting to you, why this system exists in the market? Have you ever asked the question, why this system, and it means muncul in the market? Takkan orang create product ini actually no purpose, just for selling? It couldn't be. There must be a purpose, right? I think from the words there, actually, you know, very variable, very, that means bahasa macam cakap ubah, okay, semasa ke semasa on the refrigerant side. Then refrigerant contribute into what? Energies, cooling or heating. So that is actually where you're trying to optimize. So in the facts that basically your objective of this VRF is mainly on controlling for zoning comfort and control, okay? And also basically when you are coming into control, you are actually talking about how effective the energy consumption. I'm going to optimize it, okay, by using this equipment, okay? So this equipment is actually incorporated with this screw compressor, okay? Later on, I will share with you why screw compressor, okay? Why not others, okay? So when you ask why, you may get the answer, okay? So this is actually you are able to explore yourself into that sense, okay? When we come back to this issue of VRF system, when we talk about this system, we are talking about temperature control, okay? With high responsive, whether you are in cooling mode or in heating mode, okay? I would like to take this opportunity to share with you. You yourself, especially mechanical engineer, you yourself actually can estimate by changing 1 degree C of setting temperature, how much energy gain or how much energy waste you are actually able to gain or lose from there. A lot of people saying that, ayah, baru 1 degree C tak nampak lah, tak berat lah, you know, the bahu tak berat lah, okay? So if you were to convert into ringgit, okay, it is a big amount of money, okay? Generally, I can tell you it's around 6%, okay? Whether you are gaining or you are losing, okay? There is a way of calculating by using sensible heat lah, okay? Basically, from there, you are able to basically, you convert into ringgit, wow, such amount of money, then you can see 6% of 100 ringgit, 6 ringgit saja mah. What about those big institutions and those big company having a big load, cooling load? 1 million electrical bill per month with 6%, you can see about 60,000. I can buy 1 car already, okay, proton car at least. This is the saving actually contributing into that. That's why this system actually incorporate into more precise in terms of control, okay? So hope that everybody having a better picture right now, okay? All this equipment basically equipped with the sensing device, all built in already. And this system actually self-diagnostic. With those, you are able to have those network supervisory control capability actually built into that. That's why a lot of people saying that, hey, VRF mahal, I cannot split unit saja. Yes, it's true. Berapa you bayar, berapa you dapat lah. Basically, a lot of devices control or putting inside whether you use it or not. Okay, this is actually important on that. Okay. So if you look at this, actually, this is an air-cooled outline VRF system. As you know, actually, VRF system can go for long piping. Actually, pipe length 160 meters to the furthest. Okay, this outdoor unit basically driven by DC screw compressor right now. Okay, for Mitsubishi Heavy Industry unit VRF system, this is our 8th generation of VRF. This unit is going to, this is new generation of outdoor unit is going to be available beginning of next year. So a lot of improvement on that basically have been changed. Later I share with you inside out, okay, from there. Okay, back to the question just now I posted to you. Screw compressor. Did you ever ask why screw compressor? In the market, actually, they have so many compressor. You have a centrifugal compressor, you have reciprocating compressor, you have screw compressor, you have screw compressor, you have what else compressor, you know. Okay, why this system go for screw compressor? The next slide is basically answer this question actually on that. If you look carefully on the adiabatic compression, okay, screw compressor basically perform basically with a certain range, they are better. If you are going for higher capacity range, say for example, per unit, then maybe he's losing out. Okay, you look at this blue line color, basically, if the capacity is getting bigger and bigger, the ratio of adiabatic efficiency is dropping. So generally speaking, if you look at this compressor, this is overall compressor performance, the best performance. This is actually just a guideline. At least you have a clue why with this type of capacity screw compressor is using. With a bigger capacity, another type of compressor is using. Okay, with smaller capacity, lottery compressor is using. So this is actually information may actually make you understand why there are so many compressors actually in the market. Rather than manufacturer senang saja, kalau senang, I just buat satu jenis compressor hit the world in the market. Tak perlu begitu pening, begitu banyak different compressor, right? So that is the reason behind actually we have so many different type of compressor actually available in the market to suit the most efficient performance into that. Okay, so actually our unit for, okay, this is actually our outdoor unit basically for air-cool. Okay, the pattern have changed slightly aerodynamic, but it still looks squarish lah. Okay, Mitsubishi lama dia nampak masih seketul empat segi lah. Ada orang komen masih tak cantik lah. Okay, so that is the facts. I physically you tengok macam ni, tapi we are more focused on the efficiency. Okay, performance wise. Yes, any question? Sorry. Okay, so this is actually our range of the VRF system per module base. Okay, we have a smallest capacity for 4 horsepower, look like split unit, but bukan split unit, is actually VRF system as driven by this lottery compressor. Okay, for the bigger capacity for 8 horsepower and up to 20 horsepower, we are driven by this screw compressor. So smaller unit, we have twin lottery compressor. That means compress and further compress. Why we do that is basically same thing lah. I take the same scenario. You naik tangga atau turun tangga. Okay, you dua tahap, dua peringkat naik atau satu demi satu naik senang ke atau dua tahap naik senang. So konsep yang sama. Basically, we have 2 stages of compression, compress and further compress, that makes the system more efficient and more easier. Then your consumption is lesser. So that is why our unit actually built in with actually 2-stage lottery compressor on the smaller unit capacity. Okay, so just take this opportunity to share with you. We have changed the new generations coming up. Actually, we increase the efficiency by certain model. Basically, we have a combination of say for example 20 horsepower. Last time we only have 1 module 20 horsepower with 2 compressor inside. Okay, we have new product basically coming in with 10 plus 10. 10 plus 10, that means 10 horsepower 1 module plus 10 horsepower another module. By doing that, basically you have increased the heat exchange surface area. So indirectly, basically your efficiency is actually better because you have a better heat transfer surface, okay, into that. Similarly to those highlighted basically in yellow one, basically they have actually increased. You can opt for that option basically for better efficiency. Okay, so this is actually one of the changes, actually new generation coming up with that. Okay, so for smaller capacity, So our limit basically lengthwise is up to 70 meter. Okay, if you go down, you can have a head of 15 meter. Then balance is horizontal. Okay, sorry, head of 30 meter. You can pump down 30 meter. Then balance is horizontal, 40 meter along horizontal. Okay, but your total length to the furthest is 70 meter. If your unit sitting on the ground floor, you can pump up 15 meter. Okay, so certain configuration basically you can have first branch up to the last branch. Sometimes you want to have one system serving only lift lobby, lift lobby, lift lobby. So you are limited to, for smaller capacity, you are limited to 15 meter vertical elevation. Reason is because actually we need to take care of oil return. Okay, oil return, very important, because oil return is basically is for compressor, it is for lubrication purposes. Okay, if it's exceeding that value, regardless of any brand, if you go for that, actually, can you, sometimes people is asking me, can this actually extend a little bit more, maybe 80 meter or 20 meter? I say cannot, because this system, I always tell people, air conditioning is just like human being. Why? Because just like your tangan, okay? You punya tangan begitu panjang sahaja. When you tarik sikit, apa you rasa? Terseduh, okay? Tarik lagi, putus dua, okay? For air conditioning, when you exceeded this limit, certain limit, any brand, you basically manufacturer will tell you this is the limitation. If you exceeded this limit, so that is actually not good for the unit, because when your oil traveling over there, then want to suck it back, actually oil cannot come back. When oil cannot come back, your compressor lack of oil, then the compressor fail very fast. Okay, that is the reason. We try to work within the capability. Okay, so for bigger capacity unit, the capability have extended. Basically, the head right now able to go for 90 meter, okay, all the way down, okay, 90 meter. So definitely, when you want to go for such a long distance, okay, to the furthest still 160. If you go down 90 meter, balance is horizontal, okay. If you want to go for such a long distance, definitely there is a losses also, okay. Bear in mind, basically there is a losses. So you need to compensate the losses. If any supplier, anybody tell you there is no losses at all, that is bullshit, okay. So because this is mechanical wear and tear, friction is along the line. There is a friction, okay. So there is a losses. So this is a facts and figure, facts of life. It can't change, okay. So that is the reason behind, okay. At the same time, basically air discharge. Later on, I basically will share with you a lot of job site. Basically, you know, the outdoor condensing unit, nama dia outdoor, tapi selalu locate inside the building, okay. Jadi indoor. Where especially mechanical designer consultant is facing ventilation issue. How are we going to, convince people by using a proof to say that I need at least certain amount of net free area for the system to breathe. Okay, so I noticed along my working life, I noticed basically a lot of people just saying that, sometimes when we ask, we need certain figure, say for example, I need 65% net free area. You may face the challenge from architect. Why should I give you 65% net free area? Maybe I can give you 30%. Okay, then especially mechanical, especially consultant side, you want to prove it to them. Why 65%? It's a hard time. I think a lot of people very difficult to prove to other people why I need that. Don't worry, later on I share with you all this. Okay, there's a way people have done, but have to go back a little bit, back to fundamental. Okay. Anybody still able to see my screen? Yeah. Okay. I continue. Okay. This is the outdoor, basically condenser unit putting outside, basically a roof at the rooftop, basically ventilated area. So just let those people new or student, this is actually outdoor, basically sitting outside, serving down to the floor, and we have a minimum on that. Okay, so that is on the air cool side. Okay, water cool, basically water cool VRF. To certain people, you may heard about this. Actually, now it started to getting more common on that. Okay, about 3-4 years back, actually. This system, you can see, this system, there's no fan. Okay, fan has been replaced by water in and water out. Okay, okay, as you know, water has a better heat medium transfer. So the efficiency for this water cool VRF is better than air cool, right? Unless you are next time you're able to prove that air is a better heat medium transfer compared to water. Then the physics, scientific things all reverse lah. Okay, but at the moment we still follow the physics law. Okay, water is better heat medium transfer. Okay, that's why this is the condenser unit. Features are the same. They can go for long piping. Refrigerant pipe go into different refrigerant pipe go into indoor unit are the same. You can have 160 meter all the way. Okay, but the water in and water outside is basically is going back to cooling tower. The designer then have to design on that. And this condenser unit, we call it condenser unit, is actually located inside the building. It's not exposed to outside. Okay. So this is actually a condenser unit. Okay, so this condenser, okay, physically this is a layout. Okay, you need to, this is condenser unit in multiple floor. The green color line is basically a refrigerant pipeline to indoor unit. That means you are able to go 160 meter to indoor unit. Okay, you are able to locate all these condenser unit in one location, in a room or what. Okay, the blue line color is basically a water circuit. Okay, you need to especially go for this water cool VRF. The heat exchanger is necessary unless otherwise you are using closed loop cooling tower. Why? Because cooling tower site is actually considered open loop. When you have open loop cooling tower, basically air, when you deal with air, water, 1 campur 1 is not equal to 2. Okay, you know why? Sometimes angin tiup sini dia jadi acidic, sometimes dia tiup sebelah dari kanan dia jadi alkali, then bawa apa lumut tumbul lah. Okay, then you have a total dissolved solid, that means TDS tinggi. Okay, dia akan create scaling into a system. So and on top of that, actually our condensing pipe basically is actually very small, 1 1/4 inches only, baru 34 mm sahaja. If you go direct without this heat exchanger, very easy to choke out. Within half a year, 1 year, you can see it's already choke out. Okay, so this, if you, for those people actually look into this system, please make sure you consider this heat exchanger. Okay, definitely you will create the primary pump, secondary pump. Okay, this type of system actually more involved in a control, especially the designer, how you want to optimize it. Let's say, for example, I have one indoor unit is running, then this particular indoor unit is calling for the outdoor to come in. Then this outdoor unit, okay, look at my circle, this cursor, this outdoor unit is running. Then you need to send to the pump controller to ask the pump to run. Okay, run by how much? You can run a little bit more. Okay, because your load is low. So that is how the designer able to design and configure to make the system more efficient on that. So this is actually another way you are able to optimize the usage actually on this water cool VRF. Generally speaking, this is actually a very compact, this is the size of the condenser unit. Okay, And we have a range for this condenser, water-cooled condenser unit is up to only 36 horsepower. Okay, 36 horsepower is 12 plus 12 plus 12. Compare with the air-cooled unit, or air-cooled unit having a big wider range up to 60 horsepower. Okay, so you look at the right side picture. Basically, this is a rear side picture. We have two systems. Basically, one on the top, the other actually on the ground floor. Actually, we are stacking up. Okay, to make use of the optimize the space. Okay, then if you look at this refrigerant pipe, which is insulated by this closed cells insulation, the black color one is actually going into indoor unit. Okay, your indoor unit can be ducted, can be cassette, can be anything. Okay, your blue color pipe line is actually a water circuit. Okay, water in and water out. Okay, this is actually a water cool VRF system. Okay, so in terms of water cool VRF system, manufacturer, as far as I know of, other manufacturer is more or less the same standard. Each unit per module, each unit basically is rated at 96 liter per minute. Okay, rated at 96 liter per minute, and minimum flow is 50 liter per minute, and maximum flow is 150 liter per minute. All these limitation to those designer, if we are really involved in this, all these parameter is very, very important. Okay, why? Because you need to size up your pump. You need to know the flow. Then you need to know your friction per module at different flow. Okay, so this is actually the information basically normally will be provided by the supplier. Okay, on top of that, if you look at the efficiency, ER here, okay, for 8 horsepower, 10 horsepower, 12 horsepower, generally if I average out, it's about 4.77 COP. Okay, if you are familiar with the kilowatt per ton, roughly is about 0.7 something, 76 something kilowatt per ton. This is at full load. Okay, compared to air cool, I don't compare other brand. We are comparing our air cool. Our own air cool generally about at full load is generally about 3.7 COP. Compared to this water cool COP, it's about 4.7 something. So the difference in terms of efficiency around 24%. Okay, so that's why actually water cool units are actually more efficient compared with the rest. Definitely, when you apply this type of concept, why this system actually exists in the market, because actually certain time for especially high-rise building, okay, high-rise building, architects say no, I don't even allow you to have a louvered surrounding my building. What you can do, especially as a designer, the only way you can do here is you put your cooling tower on top. Okay, then you design all this, your pump all your water to the cooling tower for heat rejection. Okay, so at the same time, basically, this is actually one of the configuration. You can see actually the black color line. This is refrigerant pipe. You can actually locate all the condenser unit in one place. You are able to pump out 40 meter, then balance 120 meter or to horizontal, or you pump down 50 meter or 110 meter horizontal. Okay. The other configuration here is you can have a floor by floor basis. Okay. Sometimes people, especially owner side, is considering this type of system not only from the aspect of the efficiency alone, because sometimes, especially high-rise building, okay, next time this floor I want to sell, different strata title, another different strata title. So especially private, I'm talking about private. The owner able to sell the different strata title at the same time. When you sell it to other people, you are still able to control, okay? Because the control philosophy of this water-cooled VRF system is still similar to those air-cooled VRF system. You are able to have those network control, as I mentioned to you just now. then let's say tenants or not tenant, the owner of that purchaser did not pay your maintenance fees, whatever, you can just electronic lock the aircon. Okay, no hardwire lock anymore. It's electronic lock the aircon. Let's say, for example, the tenant know about me, know me, ask me for help. I also have to say sorry. I can't actually access their central control because their central control, BMS side, they have their own password can go in. Need to have a password to go in, only to release the user to continue to use that. Okay, so this is actually another consideration why owner, especially high-rise building, they opt for this type of system. Some limitation on that basically, and some consideration of that. This system is actually exists in the market to suit the condition. Okay, the environment. Okay, concept just now I explained. This is how the features look like. Okay, we have this is job site in Kelana Jaya. Okay, this is hotel. We have installed on that. Actually, you can see this is for hotel room. Okay, we have heat exchanger on the other picture on the right top side. Okay, then this is the outdoor unit. Then we also have actually recently completed 40-story building, Conley Tower. Okay, we have 40-story building. As you see, surrounded the facade is no place for you to put the louvre, to put the outdoor air cool. So this is actually another way water cool come into picture basically. The condenser unit also stacking up basically. Okay, this room basically occupying 4 systems inside. Okay, this is office lot. Okay, so all whether air cool or water cool system, you are connecting into all the indoor unit. This indoor unit, you have different types to suit your interior design. You can even connecting to this AHU also. Let's say for day one, if you want to. Okay, day one, then you have a long ducting, then you can go for that. Okay, so just share with you. Actually, we have one job site actually supply using those fan coil unit and using Prihoda's Forbiduct here. Okay, this is day one badminton hall, I think in KL. Basically, it's upgrading work. Okay, so it has been running and actually quite efficient on that. Okay, so this is actually the one of the picture can share with you. Okay, the outdoor side, basically, if you look at the outdoor side, it's actually quite compact. Okay, vertical discharge. Okay, then designed in such a way, small footprint. Okay, inside for 20 horsepower, we have 2 compressor. We call it DC scroll compressor. Okay, have you ever asked another why I keep saying that DC scroll compressor? DC. Why not AC anymore? DC. Okay, there is also another reason. Later I share with you. Okay. Hope that you can pick up all these terms next time when people talk to you, at least you know something on that. Okay, especially certain time, I basically would like to talk about, okay, DC, then vector driven. I think a lot of people heard about this vector. Looks scientific, but a lot of people just ignore it. If those people are dealing with those palm, you have VSD, okay. Then you have vector control, you have fuzzy logic control. What is that all about? Actually, general term, vector. Vector is a direction. Direction, you are controlling something with a direction, either vector-driven compressor, vector-driven pump, whatever driven motor. That is the direction. Why we need to have this? Because we want to optimize the operation. Okay, this vector can be in terms of amplitude, that means magnitude, distance, velocity, acceleration. Okay, so and also this frequency. Okay, so we call it vector control. We control all these parameters. Okay, take for example, basically motor. When you deal with compressor is driven by motor, right? So this motor basically actually using electrical. So they are creating a top for compression purposes, right? So how are we going to control the top, right? You may think to those electrical, maybe he has a better understanding, okay? Just to share with you, torque is equal to K constant value divided by frequency times voltage, okay? When voltage change, I change my frequency. And this is actually where the vectors, generally vectors features actually built into that, okay? DC motor, as you know, actually, you can imagine, to those youngsters, maybe you might not be able to anticipate. To those like our age, maybe yes, bicycle, you know, you are the dynamo. Untuk lighting up when you malam, no, you are the dynamo, itu ialah DC motor. We call it dynamo, okay? Ialah DC driven, okay? Generate apa lampu untuk you punya bicycle. New generation bike, you pergi semua tak ada ini, memang tak nampak jenis inilah. Okay, if you want to see all this, go back to those authentic bicycle, then you look at that, there is a dynamo there. Okay, so that we apply that. Why DC? Because actually DC motor we build in magnetic inside to create a flux to help for rotation, so that you won't consume much energy from electrical side. You are actually self-regulating in such a way. Okay, so this is important to understand. Okay, the other term here is fuzzy logic control. I think everybody know about fuzzy logic. Everybody, I think, beside you also got fuzzy logic, but maybe you are not realized only. Fuzzy logic, what is fuzzy logic? Fuzzy logic is basically a mathematical way of controlling or programming way of controlling if then. Okay, take for example, I think a lot of people may realize that washing machine, there is a fuzzy control. Okay, beside you, your handphone, your smartphone, also fuzzy logic control. Why I say so? Very simple. If you go and take photo in the dark area, okay, the light automatically light up. Why is that so? This logic is actually able to sense the surrounding. If this condition, then what will be the next action? So the response will be faster. That actually fuzzy logic also apply into our system to optimize the usage and control the energy. Okay, so when we talk about this, is purely talking about how we optimize the energy from the soft, we call it soft skill side. It means the soft logic side. That means programming way of controlling. Other than we have hard, physical side of optimization. Okay, so with all this control, with this inverter or that, basically there's no voltage peak already, right? You don't need to size up your cable to handle all that. You just size up ngam cukup, your incoming power cukup dah. Then you actually reduce a lot of cost from the other aspect, especially electrical panel side. Okay, so this is actually another contribution on that. So the features of here is actually you are regulating the load, okay, accordingly to your demand. Okay, so system are self-diagnostic. Actually, system able to prompt you. Let's say filter sudah kotor, actually filter sign akan light up. A lot of time actually this thing happen, especially maintenance, because they don't have schedule. I actually advise them actually help using these type of features available, help them to do some periodic maintenance, or else apa aircon masih jalan, filter sign light up. The worst thing here is your indoor air quality affected. You will suck in more dust into your lungs. That is only the thing. So basically, it's important because all these features are built in. Actually, try to use it. Okay, try to use it. Okay, we talked about fuzzy logic control just now. Okay, so to share with you, this is how we control actually in air conditioning system. Okay, on especially VRF system. Okay, our outdoor unit, we have a PCB board, printed circuit board. We have indoor unit also have a printed circuit board. Then we have a lot of sensing device all built in already. Okay, we have return sensor, we have all the off-coil sensor built in, we have electronic expansion valve built in. Okay, we have a bias remote control. Then, say for example, look at this diagram. You set 23 degrees C, say for example. Unit is start running. Then this suction thermistor temperature is basically the temperature is already built in, is detecting the current room temperature, say for example, 29 degrees C. Okay, this information is basically feedback into a printed circuit board. Printed circuit board is already built in with this program, we call it fuzzy logic. Okay, some others brand, they are using different control. They may use PND control. They may use another pulse width modulation control. All that is all control, but the objective is still the same. Okay, ours is fuzzy logic. Okay, this printed circuit board will process, okay, and send the information to outdoor unit. Outdoor unit, we have inverter driven compressor. Okay, this inverter compressor basically will ramp up and send the amount of refrigerant flow into the indoor unit. Okay. So indoor unit, we have electronic expansion valve built in, okay, to control the temperature fluctuation plus minus 0.5 degrees C, okay, so that I'm able to optimize the energy. First of all, I demand, say for example, you can imagine basically satu mak 3-4 anak along the line. Mak tahu mana satu anak minta susu, minta berapa dia pun tahu. Mak akan kasih tak lebih, tak kurang. Just cukup untuk dia sahaja. Okay? This is how the configuration on that. Say for example, early morning, basically weather still cold, outdoor unit wouldn't ramp so fast, already able to achieve the demand from the indoor side. When coming to afternoon, because of sun, hot sun is coming up, basically the load increases. In order to maintain the demand, outdoor will ramp up so that more refrigerant to flow in and maintain the room set temperature actually inside the room you have set. Okay, this is how the control philosophy of this logic control. Okay, hope that you can have a better understanding by using this diagram. I'm trying to explain as layman as possible. Okay, on that. Okay. We're talking about energy improvement, energy optimization. If you look at that, just now is the soft side. That means soft, we call it the software side or soft skill for improving the control and optimization. From the physical side, you can see actually internally we have changed from the distributed winding motor become a concentrated winding motor. Okay. By doing that, basically you reduce a lot of eddy current losses on that. Okay, so this is also a contribution into optimizing the energy. Okay, so this is equipment side, physically optimizing, better improvement on that. Okay, apart from there, basically our unit originally subliminally, actually our compressor is a single port discharge. As you know, actually, our aircon control is actually by pressure. Okay, as you know, when we talk about aircon, what we talk about? We talk about pressure and temperature, right? System cukup pressure ke? System leaking ke apa? All this is we are talking about pressure. So let's just focus into compartmentation of a compressor side, especially compressor housing side. Okay. Yang sebelum ni kalau you have only one single port discharge, your pressure basically is high, something like this curve, right? So when you have a multi-port discharge, you will have a lesser pressure, but you're still able to achieve target. Area below graph is actually energy. Okay, so this is how manufacturer optimizing the energy physically inside, where outside by bare eyes you never can see. Okay, so this is internally. Okay, on top of that, just now I mentioned basically the new generation. We have actually, let's say 20 horsepower. We have equipment right now equal to 10 plus 10. This is another option. Then on top of that, basically there is a changes basically from two row of heat exchanger outside become 3 row right now. So we have increased the surface area for heat exchange. Okay, this is another way of improving efficiency. Okay, physically. Okay, the way of actually distributing the refrigerant for heat dissipation in the heat exchanger also changing. Okay, we are not using any more header side. We are actually using distributor side. Okay, we have a capillary tube. Okay, then the refrigerant actually able to distribute more evenly in the coil, condensing coil, so that the heat able to dissipate actually better. Okay, so this is actually the changes on that. Okay, improve the efficiency. Okay, so far, as you see, actually whatever I share with you, we are talking about energy and efficiency. This is some features we have actually improved and you know, to further improve on that. Okay, back to this VRF system, whether water cooled or air cooled system, you are able to go for networking. Okay, this networking is wired remote control. Wired remote control is actually a standard for VRF system. Bukan sebab ketinggalan zaman. Orang sudah guna wireless, you masih guna wired lagi ke? Ayo. No, not such a way. Basically, there is a purpose. Okay, this wired remote control, basically you can pull very far away if you want to. Okay, if you don't want to appear in this room, you can pull 500 meters away from the unit. Okay, it depends on how you configure. And this wired remote control, basically a lot of function later on I share with you actually, especially to the owner side, then you are able to control and monitor. To especially maintenance side also able to monitor. Okay, so this network cable, basically you are able to look 1.5 kilometer along the way. Then you can put a central control somewhere in your control room atau house. Then you can see the whole building's unit. Okay, for control and monitoring purposes. Okay, so system configuration very simple. Okay. Outdoor basically is actually inverter driven already. So incoming cable is directly go through this MCCB, okay, without any star delta, without auto trans, nothing. So just using MCCB directly into the outdoor. Indoor for fan coil unit is a single phase. Okay, some M is actually very low, you can share out. Okay, all this indoor unit is looping with the signal cable, shielded wire, 2 core, 0.75 mm to 1.25 mm, where you are able to travel 1.5 kilometer from end to end. Okay, then this is option like BMS control, all that. Okay, so the important thing here is this system operate by using IP address. Okay, all the indoor unit will have their dedicated IP address, exactly like your IC number and my IC number cannot be the same, even though we have having the same name. Okay, Pang also having so many Pang in the market, but the IP address cannot, the IC number cannot be the same. So this is actually the same concept. Actually, we are using the IP base for operation and networking. Okay, so this is actually the configuration. Okay, so this is actually a wired remote control. Okay, this wired remote control, why I say actually wired remote control, this wired remote control, we have a few types. One is a button type, the other one is actually a touchscreen type. Okay, they are actually very useful. Why I say so? Very simple. All these buttons, you are able to lock it up, okay, by pressing the few button and lock it up. You don't let people access, or you don't want people to touch about that. On top of that, this unit, let's say I'm the owner, I don't want people always set low temperature. Maybe I can just give them 22, the lowest. Then you lock the temperature at 22. So people press only down to 22, cannot go further down. Bear in mind, just now from the beginning of presentation, I share with you 1 degree C is 6%. Okay, from 23 degree to 18 degree, you see how many percent you go and count. the energy you are going to consume. Okay, in terms of ringgit, you convert into ringgit, then you feel the pinch. So this is actually another way you are able to do all this. For maintenance people, okay, so sorry, before that, this unit basically wire remote control, we are also able to control the static for especially for those fan coil unit. Okay, we have used these type of features basically for, you know, especially quite useful for bungalow application. Certain owner, they really don't want to hear the sound. Okay, that's why we can actually go for very, very minimum on that. So definitely airflow will be affected, okay, when you have a low static EXP, external static pressure control. But the features for VRF here is only VRF able to do that. Other system, you cannot do that. Why? Because this is, especially on VRF, when I reduce the static, okay, airflow become slower. Bear in mind, we have all the sensing device built in, right? So return temperature, I'm actually detecting the return temperature as control parameter. So when I reduce my static pressure, return temperature basically will be actually higher already, right? Because less airflow already, right? So my electronic expansion valve will be open more to let the coil getting cooler, so that to compensate the temperature difference. So only VRF system having these features to do that. Okay, normal split unit, sorry to say that, cannot do that. If you reduce normal split unit, normal split ducted unit, if you reduce your external static pressure, indirectly you are reducing your CFM. Okay, then the load is reducing, because for normal fan coil unit, normal ducted unit, the valve is fully open one, always fully open, is not regulating. So it's already at the maximum. When you reduce CFM, indirectly you are reducing the capacity in the sense that, so that is the difference between VRF system and also normal split unit, ducted unit system. So just pick up this point actually on that. Okay, so for maintenance people, or for those for those actually involving this VRF, we are able to load about 20 parameters basically show in the screen. Okay, especially for technician, sekarang the way of handling unit is all totally different already. Okay, we ask technician go down to site. Technician last time cakap, bang, sorry tak bawa tools tak bawa meter, tak bawa pressure meter lah, kerja tak boleh buat lah. No such excuse. Bawa dengan otak, dengan you punya tangan. Okay, go and press the button, load the data. Then I'm able to see the operation mode. If people set into the mode of cooling, one more thing actually I personally experience, especially the user, they accidentally press, then become a fan mode, then start complaining, not cold. Okay, so this unit I mentioned to you just now, this unit able to lock all the button. Then I now lock all the unit at the cold mode. That means I'm already eliminate one of the possibility. Things may happen. Actually, accidentally press into fan mode or press into a dry mode. So then they complain, because layman, my user, they don't care about what is all that, but they just simply press. Okay, so this is another features you can make use of it to help you for your operation. Okay, so for technician side, basically when we want to see when load the data, then you are able to see the heat exchanger. You know, you have heat exchanger temperature 1, 2, 3. This is the temperature entering the coil, center of the coil, and leaving of the coil. Then you have this berapa indoor unit ini minta, berapa mark respond. Okay, you semua tahu. Then berapa electronic expansion valve buka. Okay, if you load the data, the valve is not opening, how can the unit be cold? So this is the way actually we are able to see. So on top of that, you also able to view the whole system pressure, high pressure, low pressure. Okay, for the system. Okay, so this is also very important actually for to handle the unit system. Okay, that's why I mentioned to you air conditioning, especially airco, dia macam manusia. Dia ada high pressure, ada low pressure. Kami ada apa? Sistosis dengan apa? Ada dua bacaan lah. Okay, itu ya doktor yang kasih ya. You sendiri boleh beli Omron punya sendiri boleh actually measure you punya blood pressure cantik ke tidak. How to define cantik ke tidak? Definitely there is a guideline, right? Same thing, doctor will tell you, young man, your pressure supposed to 120/80. Itu ialah general guideline lah, cantik. If you young man is already 170, 160, 90, I rasa I think you kena ada medication atau you kena apa control you punya mulut, control you punya apa pressure by using apa learning some meditation ke, silat ke, atau tai chi ke, whatever, untuk tenangkan pemikiran, ataupun actually kalau the worst case is yalah ambil ubat咯, no choice lah. So tapi for aircon same thing, when they operate in a normal condition, they have a high pressure, low pressure. So then you need to know what is the pressure. But unfortunately, aircon cannot tell you, cannot talk to you. Oi, I dah high blood pressure dah, system not cold. Yeah, he tell you indirectly it's called system not cold lah. Okay, so you send it. So this is mainly for maintenance people, they are able to access the info. Okay. So on the other hand, actually this new generation of touchscreen wired remote control, they have all the features seperti yang button punya, okay. Tapi dia ada lagi satu we call it backup controller feature. By using that, basically you eliminate a lot of work. You especially 24 jam punya operasi, okay. Dulu kami terpaksa buat interlocking. First of all, independent power supply, okay. Then you relies on the timer, real-time clock timer. In case one power supply trip, bila power supply datang balik, dua-dua jalan balik kerana masa itu semua sudah jadi serentak. Nanti dua-dua akan stop. Okay, this is the challenges we have faced last time, but we have shifted our paradigm into another direction where we are able to actually solve this problem by using electronic-based control. We have applied this concept a lot of places already. We have few places in server room, banking system, and we have in hospital, okay, but especially in nursing area because it's 24 hours. Then we have this in others private server room also. How we do that? Basically, we are able to activate by using two numbers of indoor unit, 12 hours. Normally you check up 12 hours running and standby, connected into this one remote control touchscreen. Okay, you activate the backup control. So then semua masalah selesai. Then you tak perlu actually buat another panel untuk independent power supply, interlocking dengan timer, semua tak perlu. Why? You just electronic lock this way. As I mentioned to you, the control, we are actually detecting the room temperature as control parameter. Say for example, two numbers of indoor unit connecting, preferably from different system lah. Okay, preferably from different system. My suggestion to you is from different system. Okay, you are connecting into one remote control. This remote control is, let's say, server room. When you on this unit at the first time, okay, both unit will run. Why? Because the room haven't achieved that temperature you set, right? Both will run. Then when you achieve the temperature, one of the unit with the higher addressing number will stop. Then it will continue to follow the time. We call it time frame. How many hours you set for switching over? You can set for 1 hour to 99 hours before it's switching over. it's not relies on a real-time clock anymore. You set 20 hours, only 20 hours later, the second unit will come into picture to take over the first unit's operation. Okay, they are calling switching over rotational operation. Okay, at the same time, we have automatically having this backup capacity control in the sense that the first unit is running, not cold already due to some problem, okay, but it's not the time yet. Second unit will come in later because because first unit having problem, room temperature is increasing. The second unit will come in, okay, so to back up the situation until you go and repair the first unit lah. So if not, then the second unit will keep running already because the first unit is already satu kaki sudah sakit, okay, so that is the situation. Or the other way is the first unit really having problem, second unit immediately cut in, then to run continuously. So this is actually the features available and has been applied into a lot of places, actually helps a lot of people. Then especially those server room, because I noticed that sometimes server room, people externally install, you know, the temperature, then you put an alarm, you put into BMS system, in case one down, temperature raise up, temperature sends up, then they send the alarm to the person in charge. Then person in charge have to come in already. So by doing this, malam esok pagi baru pergi tengok lah, biar dia lah, because the second unit will come in automatically to take over the function on that. So I look at this actually is actually very useful, especially application for 24 hours. We are electronic way. This is actually an electronic way of controlling. Okay, but unfortunately there is a limit. Always in a pair. Okay, one remote control can have only two indoor unit can have one remote control only. You cannot have one remote control handle so many. That is a limit. So, but anyhow, this is actually a beauty on that. We have applied that actually, and I can share all those experiences with you. It's really useful. Or else last time actually, every time power trip, my telephone definitely will ring. Okay, so now very less ringing. Okay, this is actually another way to help the user to smoothen the operation side. Okay, so in terms of networking, just now we were talking about, okay, you can have a BMS, you put 1.5 kilometer away, then this is the central control touchscreen. Actually, for us, Mitsubishi, we have touchscreen central control. We are using window-based and Internet Explorer. There is a port for you to connect to a PC or connect to your router. Then you are able to access, control, and monitor from outside. Okay, so but definitely you got to, if you access from outside, you got to use the third-party service provider like Maxis, like Cellcom, all that. Monthly you got to pay lah. Basically, you're using the data for wireless router for controlling purposes. So I personally classified this is actually a simplified building management because we are making use of whatever is already exists. Okay, available. We no need to have a special programming on that because we are actually using Internet Explorer, okay, base. Okay, the only difference here is everything is tabulated in the table form. Okay, if you want to create something like animation lah, or any other tube, other gerak sikit lah, or water flow or something like that, sorry, this unit won't be able to do that. This unit is able to achieve on-off operation. Then you can see the temperature, you can lock the unit, and you can see any alarm or that basically in the table form, macam XL, okay, in the table form. So this is actually the limitation on that. Okay, so this is how it looks like. Okay, this is a touchscreen wire control, and then on top of that you can go for BMS. This is a high level. You are able to interface with that system available. Okay, so this is overall philosophy of control on that. So as I mentioned to you, especially outdoor, no star delta, no autotran. This is one incoming, main one pecah jadi berapa pergi individual module sahaja. Okay, so this is very straightforward on the outdoor side. Okay, so this compartmentation basically is for if you look at the circle, the cursor I'm actually pointing, this is OTA of the system. We have PCB board outside, we have display outside, then we have actually 2 unit of compressor, okay, DC driven compressor, and we have actually our heat exchanger, and also the machine compartmentation is separated by a drain pane. Okay, when you open up this, there is no short circuit. When you get the data through a PC, you can plug in your PC into here to get the data, then you go back and analyze. So there is no air short circuit onto that. So then your data is more accurate. That's actually one of the reasons we have a heat exchanger compartment is above, separated by this drain pane, and this water actually did not go into this machine compartment. There is a hose actually all the way down to the bottom. Okay, there is a hose. Nampak? Ini ialah hose. Nampak kilat-kilat sikit. This is a hose. Water semua masuk ini drain pane, then all the way down to bottom. Okay, dia tak masuk dalam machine compartmentation. Okay, so backup operation. One unit down, the other unit able to actually operate for temporarily, but definitely load is affected. Okay, this is actually system VRF able to do that. Okay, then you are able to actually control the VRF. Also depends on how you want to configure. If it's, I'm talking about just now, day one, you can configure your static for AHU. They connect to ducting, maybe using forbid duct or using other type of duct. Depends on how you want to configure. System is available. Then your outdoor unit can put far away. Okay, 160 meters away on that. Okay, some benefit basically onto this system is I mentioned to you actually reducing the installation cost, especially because this is single collective piping. One pipe pergi cabang keluar kiri kanan all the way. Okay, then individual unit boleh operate individually. It's not affecting the rest. The load is changing according to the demand. Okay, kalau sunlight actually shining on your classroom, your glass area, maybe lebih panas sikit, you punya valve akan buka lebih. Okay, nanti sudah petang, maybe sunshine sudah tak ada, basically valve set temperature yang remain sama, you notice that the valve is actually opening lesser. Okay, this is actually suit the operating condition. Okay, one unit failure does not affect the rest actually. Okay, so as mentioned to you, network control. Okay, this is important. Basically, our controlling temperature fluctuation is actually plus minus 0.5 degree. Okay, this is also contribute into energy. If others normal system is basically plus minus 1.5 degrees C. Okay, so temperature fluctuation is actually the higher the temperature fluctuation, the more energy you are actually more consuming. This can be actually imagine like those lorry sentiasa jalan dengan constant speed atau regular speed, instead of stop jalan, dia consume more energy, right? So similar case lah, similar case. Okay, so unit basically, especially indoor unit ducted, you are actually having able to eliminate those long ducting work lah, basically. Then you improve your comfort lah. Okay, by using a better air distribution. Like forbid duct is one of the way actually improving comfort by distributing the air into the space actually more evenly. Okay, into that. Okay, noise level, yes, contributing to reduce on that also. Okay, indoor air quality. What I mean to say that I mentioned to you, our unit actually built in with those cell diagnostic chromium air filter sign light up. It's time for you to service. Okay, you can set the longer period for the filter sign to light up, or you can also don't want this filter sign to light up. Also, you can do that, no issue. It's up to you as a user personally how you want it to be. Okay, so saving in terms of project site, saving in terms of electrical panel. Actually, in the beginning stage, basically you can see that is all the saving already on that. Okay. Startup, no star delta, no autotrans, basically component or no need. No need to oversizing the cable. No need. All this no need. Okay. So conventionally, yes, because it's star delta, they have to take care of the kit of the incoming power, right? You have a startup, okay, star, then change it to delta. So you need to take care of maybe 1.4 times or 1.5 times of the incoming, of the power. That's why a lot of people ask me, especially in the catalog, why my starting M lower than my running M. Okay, so because there's no starting. Okay, so my running M is running M, maximum running M. So this is the difference actually from the rest of the component. Okay, so DC driven compressor basically having a richer, faster temperature and no voltage peak yang just now I mentioned to you. Okay, just let me share with you. Talking about so many, just now talking about energy saving, you may ask me, ada proof ke? Macam mana you cakap you energy saving? Okay, basically some UTM site, Johor, they have done all this study. Basically, just share with you, they published in the internet. Okay, this is faculty education, I think few years back, they have done it. Okay, untuk bilik-bilik pensyarah, they are able to actually having a saving around to 39.5% of energy saving. Okay, they really study before changing 1 year. Master student lah, sekolah actually dia banyak student, especially mechanical side, boleh bantu atau boleh create this as a project untuk mereka. This thesis is actually taking about 2 years. 1 year before upgrading, they're capturing all the data. They also do something like market survey. That means the occupants there, they interview berapa selesa, berapa kali you complain in the satu bulan, all that they capture. Okay, so then after that, after upgrading, what will be happening? They are doing the same thing. So they actually publish into that. This is actually they did publish into internet, and just I download and share with you all this. Okay, you have some saving on that, roughly about 39%. This is all the bilik-bilik lah. Okay, pensyarah. This is UTM Skudai, I think block C, faculty engineering, faculty education, block C19, if I'm not mistaken. Yeah. So they are comparing the previous system, chill water system, compared with the VRF system. This is one of the unit lah yang actually sudah buat tu. Okay. So before that, actually up to even much earlier, there was actually two lecturers basically do a research on this control. Okay, I think it's early 2000 plus. Okay, they have done all this. Okay, but one is from Indonesia, Henry, and the other is actually a professor in Malaysia here, UTM also, Maknavi. What they do here is basically, you can see the keyword here is variable speed proportional control, energy saving in air conditioning. Okay, this is their finding. Okay, they are using the same concept where the VRF system already available, they apply into those conventional system. Okay, they put a sensor into the room, then they put a controller into that, then they have an inverter driven the motor. Okay, same thing when room temperature achieved, then they will ask controller slow down the motor, slow down the compression, right? When you slow down the compression, the less refrigerant travel into the coil, right? So you are able to achieve your room temperature. Okay, just let us, this is talking about their controller, okay? Their logic control, their PNID control. So just look at their finding. Okay?
Mr. Pang,
This
sorry,
Mr.
Pang.
Yeah.
Actually, we cannot see your link. Just.
Oh, cannot see.
Yeah.
Oh, okay. How am I going to make you to see the link? Wait.
Share or reshare the. You just share the.
Just share. Okay, give me a minute. Okay, new share.
Lepas IT korang pergi mana?
Wait lah.
Lepas IT korang buat CPR dulu kan?
Yeah, now we can see.
Okay. Oh, the
Hello, Mr. Pang? Hello, Mr.
Hello.
Pang? Hello, Mr. Pang? Still on the line?
Hello.
Kita tunggu Mr. Pang untuk reconnect back. Sementara kita nak tunggu Mr. Pang, mana yang ada nak bertanya soalan boleh tulis dalam ruangan komen. Okay, Mr. Pang ada masalah connection sikit. So, kita tunggu sebentar. Sementara Mr. Pang nak recover balik dia punya line. Okay, sementara tu kita boleh, kalau tuan-tuan ada nak tanya soalan berkenaan dengan VRB, dengan sistem yang terbaru daripada Mitsubishi ataupun sistem yang previous, berkenaan dengan maintenance ke, installation ke, tuan-tuan boleh tulis dalam ruangan chat. Nanti kita akan bacakan kepada Mr. Pang. Okay, so kalau tuan-tuan ada nak tanya soalan, boleh type dalam ruangan chat. Ataupun nanti kita akan beri kebenaran lah untuk ruangan question and Q&A nanti. Tuan-tuan boleh buka mic lah. Nanti kita akan bukakan beri kebenaran untuk tanya soalan. Okay. So, prevention pest. So, Mr. Anas Ghazali ada tanya soalan ya. How about the prevention for pest from come into PCB board? Okay, so discuss this one common problem for my side. Okay, Mr. Anas, nanti kita tunggu Mr. Pang masuk balik ya. So, beliau tengah recover dia punya internet tu. Okay. Aris, dah ada Aris? Mr. Pang dah ada dalam line ke? Tunggu sekejap ya.
Belum. Tak masuk ni.
So, mana yang belum isi sertifikat boleh letak apa tu? Nak minta sijil ke, nak boleh letakkan fill up. Nanti admin kita akan buatkan satu sijil lah untuk kenangan bersama dengan Mitsubishi ni. Okay. So kita boleh rehat dulu sekejap ya. Sementara kita tunggu Mr. Pang anytime dia akan masuk balik. Okay, so memandangkan Mr. Pang belum lagi boleh recover balik tu, kita rehat dulu ya. Kita rehat 5 minit dulu. So nanti kita sambung balik lah. Okay, kita boleh take 5 dulu, take 5. Nanti kita sambung balik, okay? Alright.
Sorry, interruption. Sorry, I'm back. Sorry for this technical unexpectations, the technical error. Yeah, sorry.
No problem, no problem.
Maybe just take a time for a break lah. Consider as a break time lah. Okay, sorry. Okay, sorry. Let me come back to here. Just now I'm talking about the energy all the way. So people will ask how much actually saving this system actually able to contribute. Okay, some study people have done actually, especially UTM, especially the master student. This is master student project. I just share balik. Semua nampak this screen? Hello?
Belum lagi Mr. Pang. Tak nampak lagi slide.
Tak nampak.
Tak nampak lagi.
Tak nampak kejap I share lagi. Okay. Ini nampak?
Okay, sekarang sudah nampak energy study on central variable.
Okay, energy study. Yes. This is a UTM punya master student. I think about 2012 ke 2014. Dia spend 2 years untuk study ini sebelum upgrading dan selepas upgrading. This is a block education. Apa yang finding ialah dia dapat 39% of optimization dari segi tenaga. Dia also actually do a lot before they start this project. They do a lot of survey. They actually interview those occupants there. How many times you have complained using especially on aircon, okay, in a month. So all the statistic dia compose semua statistik ini actually untuk dia punya reference lah. Okay, selepas upgrade 1 year, selepas upgrade to VRF system, dia do the same thing also. So they actually tabulate and analyze it up. So using VRF system actually for institution, especially bilik pensyarah, they are actually able to optimize further on that. Okay, at that time actually our system is generation 4. Okay, comparatively generation right now more energy saving. Okay, so this is all the finding actually you are able to download from there from the internet, then you can see. Okay, the other thing is the other survey, the other study. Can everybody see the slide?
Yes, boleh.
See, this is another one. This is a study, a PDF. Energy saving for air conditioning with variable speed of proportional control. Nampak tak? Hello.
Nampak.
Nampak? Okay.
Nampak.
So, okay. This is actually long before actually the VRF system getting famous in the market. Two professor, Henry and from Indonesia, and also Maknawi from UTM Skudai also, actually they have done all their research on variable speed proportional control energy saving in air conditioning. Okay, so if you look at this, actually they are they are placing the same concept of control which is available in the VRF system into conventional unit. So you look at this diagram here. They are placing a sensing device, they are placing the controller, they are placing the inverter to drive the motor. Okay, so the motor control the compressor to send the amount of refrigerant into evaporator. So sensing temperature dah dapat, then dia panggil controller slow down the motor. So this is actually the corresponding reaction into the system, how they optimize it. And this is talking about all the PNID control. Okay, now I would like to share with you their finding. Okay, this is all the data they have captured. Just look at this diagram, P control. If you look at this, actually, when they are running at full load, roughly around 2.5 kilowatt consumption, right? If you have a P control, that means they are using a PNID control. So this is actually the fluctuation graph yang you dapat. Okay, bila sudah cukup sejuk, I ramp down. Bila panas balik, I ramp up. All thing. Okay, fluctuating this way lah. Okay, if you take a prorata of this blue color line, generally about 1.8 lah. This is actually less than 1.8 lah. 1.8 divided by 2.5, easily 25%. You are having a saving on that. So this is actually to basically already prove that you are able to optimize actually your usage, energy usage from the VRF system, which is all the features is already available inside. Okay, so this is on that. Okay, come back to here. Where am I? Give me a minute. Sorry. Yeah, right. Tadi. Yeah. Mana saya? Yeah. Yeah. Okay. So same thing. Because system outdoor unit is actually operate with multiple module. The unit people will ask, kalau such a way, because the unit is basically able to operate self-regulating and equally operate time operation equal out equally, so that dia punya minyak akan lebih stabil, dia punya operasi time lebih stabil. Look at the operation. Let's say, for example, I'm running at full load right now, all the unit running.
Mr. Pang,
So when you part load, yeah.
Do you share something different? We only see the graph only.
I see the graph. No, I'm sharing this my presentation file. Give me a minute.
You stop back, then reshare back.
One more time. Kejap. Okay. Mana saya?
Bertenang. Minum dulu Mr. Pang. Sudah lama cakap. Minum dulu.
Panik ini teknologi terlalu tinggi, orang tua tak tahu guna.
Muda lagi lah.
Muda lagi lah. Nampak muda tapi sudah tua.
You stop share dulu, nanti you reshare balik.
Stop sharing. Resharing balik. Okay. Right.
Reshare window tu.
Okay, I share balik lah.
You select window.
Okay, yeah. Okay, nampak lah.
Okay, now sudah nampak. FDC KSZ.
Yeah. Okay. Sorry, interrupting again. Sorry, really sorry. Okay, and when we talk about multiple module, basically sometimes people will ask, hey, the next module, if I was running a part load, the next module will never run. But it's not such a case. Basically, when you run a part load, say for example, this is actually the operation wise. When you run a part load, the first unit will come in first. Then if your load keep increasing, the sebelah punya masuk, and sampai you full load semua masuk. Bila you part load balik, the first unit tadi actually in the picture will go to rest. Okay, and continuously the following lah. Okay, same thing to the next cycle. Tadi yang jalan modul yang pertama sebelah kiri, sekarang second cycle unit yang kedua lah, yang modul yang kedua lah. Dia sendiri akan basically even out the operation time. No need to worry about this. Okay, there's no issue at all. Okay, generally, look at internally, slightly more detail on that. When the system is in operation, okay, the compressor is compressing the refrigerant. This refrigerant will go into this, we call it oil separator. They will separate the oil and coming back again. So refrigerant will travel into untuk buang haba. Okay, so after buang haba, basically it will travel back into this. Actually, kami ada subco. Okay, this is a subco, further cooling of the liquid refrigerant. After that, you are traveling into all the fan coil unit. This fan coil unit, you ada electronic expansion valve over here, EV valve here. Lepas tu dia akan expand. Bila dia expand, dia akan jadi lebih sejuk. Dia serap haba, dia patah balik accumulator, then they come back to a compressor. This is the cycle of operation. Okay, the cycle of operation. Okay, so hope that you have a better picture how this is closed loop. Is closed loop. Okay, okay. Bila dia tak kotor, mean dia tak akan kotor. Am I right to say? Okay, so back to my first question. Do it right at the first place. At the first place. Okay. So this is actually the pipe ni. Ini lah pipe lah. Okay. This is actually the unit lah. Nampak component side. Okay. Okay. When we now it's more important we talk about this. Sorry Cik Mazlan. Boleh saya minta lebih masa sikit lah. Banyak nak share deh.
Boleh.
Boleh ya.
Kalau
Kalau
selagi ada orang datang tengok boleh share, tak ada masalah.
Okay. Thank you very much. Okay. First of all, I would like to mention to you here is do it right at the first place. When you do any project, basically do it right at the first place, especially installation. Okay. When you talk about installation, ventilation is very important. Okay. Dia macam manusia. Bila you tutup dia, apa kesan? Kesan ialah darah tinggi. Sistem high pressure. Okay. Kalau kami tutup kami punya hidung sebab sesama, you rasa selesa tak? You memang tak rasa selesa lah. Okay. You memang akan darah mungkin lebih tinggi sikit lah. The whole body is uncomfortable. So there is a minimum space required to make sure that aircon is actually function. Okay, well function. So this is actually the recommended from manufacturer. That is a minimum required. You boleh refer to different manufacturer, different manufacturer punya requirement lah. Okay, so I just take for example on this. Okay, say for example, a lot of job site actually I show it to you here is this is one of our job site. Basically, you tengok atas actually bumbung dia keluar untuk tadahan, angin tak keluar dia patah balik, dia high condensing. Okay, so this is the way actually angin kena dia patah balik. Okay, angin don't expect because this is propeller fan. Don't expect you tengok macam ni, oh just ngam-ngam selari dengan atas tu angin tu straight keluar ke langit. Tak ada. Dia memang actually divergent. Okay, dia cone terbalik. You cuba imagine angin profile ialah cone terbalik tiup ke atas langit. Okay, when you hit this, actually they're turning back. So high condensing. The only way to solve this is actually you install the duct to guide the hot air one way out. Okay, this is a solution. Okay, so same thing to certain space. Just now I mentioned to you. Sometimes outdoor actually is at the place where it's actually a confined space. Okay, they have a lot of blockage, including this luwet. That's why you tengok bawah punya luwet semua sudah buka supaya angin boleh masuk. Okay, bila angin masuk, dia sedut, dia discharge to the top. So we need to create this cross ventilation. Okay, it's important. Okay, so same thing lah. When block ke semua tu, this is actually the situation. We got to make sure that aircon is actually well briefed. Okay, when the unit is in operation. Okay, so similarly, this is actually another building to show it to you. The picture on the left is before. and on the right is after top of the view, top view. Actually, this is inside a well, 4 segi. 3 bahagian dinding tinggi about 4 meter, satu side luwet. Tapi luwet ini memang actually tak nampak luar. Basically, antara satu sama lain. Yeah. Hello? Yes, sorry. Luwet ni basically actually angin tu susah nak masuk. Okay, this is luwet is terlalu compact. So that's why you can't have a cross flow. So hot air is pushing up. Basically, you got no cold air coming in, even though it's outside. Okay, open space. So these also have to take into account. So especially the luwet pattern. Okay, so it's important. Okay, before and after. Okay, so same thing. The unit sitting inside, then your luwet wider will be better. Okay, you got to make sure you see actually. Because this is sitting inside, you can see on the right picture, actually our unit we raise up slightly so that air can go beneath into the second row, okay, to make the system more workable. Okay, we try to prevent all this high condensing unit because sometimes this is only space allowed to place, so this is actually the challenges we have to take into account. Okay, so come back into this. This is, I think, more important. I would like to share, especially to those students. I think you are more familiar with those formula. To those has been working, I think hardly you are using formula. This is actually the way we want to prove it to anybody saying that we want some net free area. Please prove it to me. You claim you want to have 65% net free area. How can you ensure that? And the system is working. Okay. Rule of thumb to share with you, generally for general aircon air-cool, discharge is around 4.5 to 5 meter per second. Discharge velocity. Air intake is actually around 1 to 1.6 meter per second. Okay, air intake. This is actually for better air change. Okay, how to come up with this? They have actually all studied. If your discharge is too fast, air intake is too fast also, basically there's no heat transfer. Okay, so generally for everybody, this figure is a guideline for you to help you next time, basically to size up roughly how much you require. Okay, you can see the unit better perform or not. Okay, so take for example here, we have to go back to a little bit to basic fundamental. Guna formula yang dulu cikgu ajar. Okay, tapi dulu cikgu ajar itu dia tak ada kait kami dengan industrial reality. Okay, that's why kami banyak ramai orang tak nampak how lepas kami belajar PV, pernah dengar PV equal to MRT kan? MRT, PV equal to MRT. I rasa to those mechanical students, this is a very common, right? Thermodynamic, okay, ideal gas. So this is actually the formula actually we all apply. P stands for pressure lah, velocity V lah, A is the area. Okay. Take for example, based on Mitsubishi punya, kami ada discharge 50 PA. Okay, so a little bit on calculation. If those people don't like calculation, doesn't matter. Later on, I will share with you where you can find those tables to help you to sort it out this issue. Okay, so we need to go back to fundamental a little bit. Flow Q equal to A times V, where area times velocity. Mass flow rate is equal to density times A times velocity. Okay, no need to remember all this basically. I just want to basically bring you through here is flow is proportional to velocity, proportional to area. If the area reduced by half, imagine if you have dug out, basically you are the luwet tutup. Okay, reduced by half, net free area. Okay. Bermaksud your area A2, 2 kali area A2 equal to A1. Maksud I refer to balik slide ini ya. Area A1 dekat sini, area A2 dekat bahagian P2 sini. Okay, mulut untuk angin keluar. Okay, so when you do that, basically your flow also reduced by half, right? Because is Q is directly proportional to area, right? At the point 2, okay, your flow is actually become 2.25 meter cube per second. Okay, because your original discharge here is actually double, right? So because of you have reduced your blockage, you have actually increased the blockage, your flow also reducing. Okay, so then the flow is reduced, then your velocity also reduced. Okay, logic, huh? This is actually logic because based on this formula. Okay, so further deeper a little bit, then you can use the minor losses formula to go and calculate what is the minor losses. Then your pressure losses across a 90-degree band static. Okay, you boleh calculate based on equivalent length. Okay, and then you are able to calculate. Then you have minor losses punya tu. Then you have equivalent length punya. Then you campur lah habis tu. Then you corresponding to the pressure P2. Saya nak dapatkan P2 over here because my discharge is actually 50 PA. Minus the losses of ducting, minus the losses of fluid. Okay, what the pressure I remain is 50 PA tolak ini to 18.7 tolak 6.93. Then you got about remaining about 24.37 PA only. PA only. Okay, now come back to this isothermal process, perfect gas. PV equal to MRT. Okay, those students, I think you are more familiar, then easily you can recall, and also you can actually work out the work done. Okay, per unit volume, this is all the formula. You can plug it in, then you can also actually calculating the efficiency losses due to you cover up the applying the fluid onto a area of discharge. Okay, sama sajalah when you tutup you punya sebelah hidung. Okay, 50%. What will happen? Okay, you can feel uncomfortable. How uncomfortable you are, you only know yourself. Other people don't know. Okay, so that is another way. Basically, you can see the efficiency losses is quite great. Okay, on that. Okay, based on this. Okay, doesn't matter. We don't care about how this calculation actually is sometimes very you already left the school so long ago, then you ask to come back to calculate all this formula. Okay. Another way to share with you, easier way is you go to this, you go to internet, you search for engineering data, you go to look for these minor losses. Okay. Somebody have done all this for you. Okay. I just capture a little bit of the info and share with you. Grill 0.7 ratio net free area, dia punya minor losses factor berapa, dengan grill 0.2 ratio net free area, maksud 0.2 maksud dia tutup 80% lah. Okay, 0.7 maksud dia tutup 30%. Okay, so this table, there is another table for you. This is a table corresponding to the velocity here. Then you immediately know what is the losses. Okay, at this velocity, then corresponding to the minor losses, then you are able to know what is the losses. Then you have your own original pressure, you minus the losses, then you have a remaining how much. So this is another way, easier way for you to work out rather than you go through formula by formula. Okay, everybody, you can just go into the internet and looking for this engineering data, minor losses. People have done it for you easily, then very conveniently. You can pick up from here, more or less there, actually not far away. Okay, so it's good for you to actually know about this. Actually, when people ask you to prove, okay, how much actually my energy losses going to incur by tutup sini, tutup sana. Okay, this is actually important. Okay, so bila kami tutup semua ni, come back to especially aircon. I think this graph, everybody familiar, right? This is called Molière chart atau kami selalu panggil pH chart. Okay, thermodynamic memang ada. Okay, different refrigerant having a different characteristic. Okay, so this is a Molière chart. You nampak dia gerak, kami ada condensation, ada compression, then kami ada evaporation. Kan? This is a cycle. Okay, 410A, this is a cycle. 410A having a 410A characteristic. Okay, if let's say for example, you have just now cover up maybe 50%. This curve might shift. Is definitely shifting from the original position, right? Because the characteristic have changed. Similarly, I just now give you an example. When you, young man, doctor say supposed to be 120/80, you punya tekanan darah itu baru normal. Tapi sekarang you sudah 150, 160, dan 90 atau 100. The person may feel maybe pening-pening, letih. This is a symptom basically because it's already out of the kemampuan body boleh handle. Because body perlu ada salur darah itu basically handle certain tekanan pressure. Similarly to air conditioning, this air conditioning characteristic for R410A refrigerant, they have the certain pressure, low pressure berapa, high pressure berapa. So this is the right pressure supposed to be. If you cover up sini, cover up sana, this curve is shifting, maybe shifting higher up. So high pressure getting even higher pressure. Low pressure is also given higher pressure. So it's actually system won't be cold. Okay. So this is actually important, basically to understand. Okay, into that actually, especially you are dealing with air cool. Okay, whether air cool for normal air cool VRF atau you deal with the cooling tower, dia perlu ada minimum space. Okay, for ventilating. Similar. Okay. Come back to the leeward area. Kami nak estimate actually leeward area berapa perlu. Okay, berapa perlu. Okay, in order for the unit to operate in a normal condition, P2 shall be bigger or equal to at least 2/3 of the original pressure. Means to say that here, sorry lompat balik a little bit here. P2 discharge here. At least kalau you tutup, at least masih ada 2/3 of P1 lah. P1 dekat tempat discharge original punya. That is actually important. Okay, for the operation, for the system to operate. Okay, okay. Back to again. Isothermal process, PV equal to MRT. This is actually the formula. Okay, P proportional to mass flow rate and proportional to flow area velocity. Okay, so you nampak ini actually bila at P2 you ada any pressure of this, then you roughly know what is the pressure remaining sebab you tutup. Then you boleh guna formula P1 V1 equal to P2 V2, then you boleh calculate original area dan discharge berapa, then you boleh actually calculate the losses. Okay, dan work back the area, original area berapa you masih tinggal. Okay, so total percentage losses you boleh actually work it out is actually sebenarnya you sudah tutup about 35%, so you punya net free area remaining 65%. Okay, so you know I need at least I perlu 65% net free area. Okay, say for example this is a leeward side. Okay, cross sectional, let's say for example 8 inci leeward. Okay, so biru punya ialah leeward lah, kawasan biru. Kosong punya tempat ialah net free area. Berapa saya perlu? Saya perlu at least 65% net free area untuk tempat kosong. Then tilt angle berapa? So in fact actually with this net free area you are able to calculate using a tangent. Okay, using as a back to school again tangent beta equal to berapa jarak times berapa ni, then you akan dapat angle, tube angle of this luwet. Okay, so generally to say that, basically I can tell you, if you're from the horizontal rule of thumb, horizontal, if you want to tell people what is the net free area you require, you say 65%, and tube angle is actually maximum 22 degrees from the horizontal. That is a maximum. Okay, so you are, in that case, you are safe. Why I say so? This is actually the past exercise I have been doing, basically for one of the project. Then I put my neck to ensure that system is in operation. If not, I'm the one who is going to hang myself to do that. Basically, there's no issue. I'm confident to do that. Then that's why I've done it. This unit, this area has been running about 5 years already. So I'm confident. That's why I take this opportunity to share with you. This is the information for M&E consultant to know sometime, because of owner asked to prove how you claim you want this 65%. This is the way actually you can calculate. Sorry to say that sometimes you got no choice. You got to back to school a little bit, then to do all these things. Okay, so that's why certain job site before and after. That's why you nampak this is a sitting hotel in Masjid Jamek. Okay, unit you tengok tempat discharge area. I have to actually remove the luwet so that to create more net free area. Okay, by looking at this, the left picture, you can see actually it looks like actually a lot of space, because your angle of you look up is actually just nice at the angle of this luwet. If you look horizontal, memang actually very small gap. Okay, so similarly, other job site, this is the luwet pattern. Okay, so certain installation, basically, I would like to share with you this type of installation actually not so good, but sometimes you got no choice because the unit is sitting inside the building. Then on top there is a slab, so you got to pushing almost like N shape. Okay, then turning another 90 degree, turn to discharge to the other side. Okay, so no choice. But lucky this side ventilation still okay. We are able to handle that. There's no issue. Okay, so that is on ventilation. Secondly, we are talking about flushing. Very, very important actually. When, as you know, this current situation, people is using a brazing. Okay, we always recommend using nitrogen to pass through when you do a brazing, but a lot of time this actually did not practice. Then kesan utama, okay, to show it to you. Kesan utama ialah ini. We want to do it right at the first place. I always say, okay, because actually I would like to show you the picture. Okay, flushing, satu flushing, number two vacuuming. We want to achieve 500 micron reading. Okay, this is actually a 500 micron reading to show you. Bila I achieve 500 micron reading vacuuming, lepas you dah connect all your pipe, vacuum, cuba tengok the temperature inside the pipe is minus 25 degrees C, which I have not charged the gas yet. Okay, it's already minus 25 degrees C. Okay, I need to vacuum until at least 500 micron. Okay, to get this. Okay, to ensure the system really perfect. Or else, basically, such a low temperature, if you top up the gas inside, then the system definitely more efficient. Okay, so this is without gas. The gas haven't top up yet, then it's already achieved such a low temperature. Okay, so back to flushing. Just now I said if you are using a normal way of doing, you are brazing the pipe. Basically, if you are not using nitrogen to pass through, inside actually oxidizing. Bila oxidizing, actually oxide apa tu, semua kotor punya akan travel and stuck at the strainer. Can you see all this strainer almost about the picture, the cursor saya tunjuk tu almost 95% stuck. Okay, and and this is mixing with oil, it becomes sticky. Okay, this is a strainer. Basically, inside strainer we have a netting. So basically to filter all the debris. Instead of this debris going into a compressor, then compressor koyak. Tapi because of dirty, all the oil cannot travel, cannot pass through. Then your compressor lack of oil, the compressor also fail. So this is actually the important thing. Okay, you can see in the diagram just now I show you the flow of the system. They have so many strainer along the place. Actually, this is at the outdoor side. Those circle one are actually the strainer to capture the system. If I say, if you do job actually beginning from the first place, do it nicely because it's close low, dia bersih, guarantee dia akan permanently bersih, dia tak akan kotor, right? So this is important. We say, I'm keep emphasizing, do it right at the first place, okay? Failure to do a phrasing, okay? You can see these two picture. Left picture is you don't have nitrogen to pass through, you brace it, okay? After brace, potong dua, tengok dalam apa yang you nampak. Compare with yang other nitrogen lalu, okay? If you have nitrogen go in, basically there's no oxygen inside. There's no way of oxidizing, okay? Those are oxidized inside, become a black in color, is a carbon, okay? Stick to the wall, okay? But you got to bear in mind, this refrigerant always travel 15 to 20 meters per second, okay? Sometimes contractors say, oh, I have brazed it, then I do flushing. Yes, I do flushing. When he do flushing, those items nak keluar punya sudah keluar, tak keluar punya kekal dalam, actually stick to the wall. Okay, but my concern here is I cannot ensure that how long this will peel off, because the refrigerant traveling is about 15 to 20 meters per second, very fast, and there is a friction. Then this might peel off gradually. One day, all these peel off, then it is actually dilute into the refrigerant or oil. It travel and stuck at the netting there, at the strainer. So when it start, oil cannot pass through, then your compressor koyak. So this is actually the consequences of without nitrogen, flushing, without nitrogen passing through when you are doing a brazing. Okay, so this is actually a important point to be taken. Okay, so those debris actually, you can see all this is picture. Those debris actually come in, able to find inside the compressor or inside the tube. Okay, so all these are okay. So another way to solve this problem, that is another way to solve this problem is basically there is we call it cold joint. Okay, we are able to solve this. We have actually do this one experiment 3 years back in one of the job site using this cold joint. First is actually fast. Secondly is actually no hazardous, no fire hazardous, and no skilled people. Even the limited space you are able to do. Okay, this is one of the technology I think from Germany. Okay, able to do that. Basically, job is do it very fast and also very neat. Okay, so this is actually the correct 3 points technology. When you clamp it, actually the surrounding 120-degree angle, they are clamping each other together with the fitting. Okay, so they are able to withstand 48 bar. That means after clamping, this joint able to withstand 696 psig. You are able to test that pressure. There's no issue at all because our unit normally we only test up to 500 psig. Okay, so inside this joint basically there's an O-ring. Okay, this O-ring basically they have this HNBR O-ring. Okay, this is the O-ring as you see in the slide. Actually, this O-ring able to withstand this critical temperature -40 to 120 21 degrees C. There's no issue at all. When you clamp it, this is cold joint, then there's no oxidization at all in the pipe. Basically, you save a lot of hassle on that. Okay. In industry, there's some industry already start implementing this. Okay, 3 years back. So far, so good. There's no issue at all. so far so good lah. Basically, this is another way you may consider to opt for to go for connecting those piping. Okay, so advantage is I mentioned to you, no need to have skilled people, no fire hazard. Okay, those very limited space connection also you are able to do that very easy. Then the most important thing is internally is clean, then your system is actually life is prolonged. Okay, life is prolonged. Okay, so talking so much actually on that. Okay, once you do it right at the first place, your maintenance basically become lighter. Am I right to say? Because you don't have the issue of contamination internally, compressor fail lah, apa oil tak return lah, whatever, all this type of thing. So your maintenance become lighter. So you just normally do those maintenance like visual checking, indoor operation, blower, definitely because the unit is in operation, wear and tear may incur. Okay, you may have some abnormal noise after a few years down the road. Okay, so you boleh check actually from visualization, observation. Okay, filter cleaning, pump, all that. Basically, this is a very simple work actually on the indoor unit side. And the outdoor unit side, basically, you normally will check the refrigerant pressure. Okay, then all that lah, dirty, then clean up lah. Okay, then observing physically. Okay, those the fasten, especially those connecting point, especially electrical, because after a certain period of time, bila unit jalan dia ada gegar, mungkin dia boleh lose state, especially on electrical, it can create sparking. Okay, you might make sure actually all your connection, cable connection, all fully tightened. Okay, to make sure no issue on that. Okay, so in terms of electrical side, basically make sure that your earth circuit breaker is functioning. Okay, tighten all the joint or corrosion, the breaker is functioning. The rest basically not much lah. Basically operation, you got to check the system operation. Okay, one more thing basically I would like to share with you here. System, when they are always in a normal operation, when you full blast, you compare with your testing commissioning data, the pressure is there. No need to top up gas. Okay, please don't simply top up gas because you are going to create a beban into a compressor. The additional load overload into the compressor because it's too much. Just like human being, I think everybody may notice that, especially certain kanak-kanak, dia makan tak henti punya, dia tak boleh control. Makan. After up to certain time, dia muntah sendiri. Nasib baik actually, manusia able to reflect muntah sendiri. Lepas muntah dia selesa. Sorry, terus tidur selama-lamanya. Okay, so it's important. Don't simply charge gas into that. Make sure system pressure is enough. Cantik, kalau okay. Okay, so that is the things you need to take into account. So in terms of general maintenance, especially like a filter cleaning, normally monthly lah. Okay, then you check your fan coil ke, you check your drainage ke. Okay, then cleaning normal service mainly 3 bulan sekali untuk outdoor. If your outdoor is very near to restaurant, maybe you perlu monthly because it's very oily. Okay, but generally 3 months sudah cukup lah. 3 months bersih sekali. Make sure you bersih lah, betul-betul bersih. Not just guna mulut dengan kertas bersih saja, tapi pergi site memang actually langsung tak bersih. Chop size semua sudah bersih, tapi site memang tak bersih. Teruk lah. Okay, so pernah berlaku. So this is the thing. So we want to do it. We do it right. Do it nicely and do it right at the first place. Generally, you can see this is actually apa yang you perlu buat. You got to check the system pressure, the amp lah, all that. This is on normal side condition. To share with you, this is a few site We have, I think everybody Syam ini mana tempat parliament. Okay, we have our unit there. Basically, unit tak besar. Actually, bahu berat lah. All the VIP, all the menteri there, semua sana. Okay, so we have in Mahkamah Duta also we have a central control. Okay, all this is ducting. We got to make sure that actually well ventilated. Okay. So this is another job site, open space. Okay, this is UITM. Okay, so pre-insulated pipe. Okay, so nampak kemas lah. Okay, so UTM's Jalan Semarak. Okay, this is MRT. So pre-insulated pipe. Okay, this is old site actually in Parliament. Okay, so just would like to share with you this actually some information. I basically hope that you can gain something from here. Yes. So my end of my presentation. I hope you're having something you are able to gain from here. Yeah. Thank you. Mazlan.
Yeah.
Yeah, Mazlan.
Okay.
Is it Mazlan? I finished my presentation.
Okay.
Yes.
So ada few questions.
Ya, sebelum mereka tanya, biar saya tanya dulu ah.
Boleh.
So that saya punya gift boleh diagih keluar mah.
Okay, sebelum tu Mr. Pang relax dulu. Okay,
Yes.
semua dia minta bersedia ya. Mr. Pang akan bertanya soalan, kita akan bagi hadiah pen eksklusif daripada IMZ ya. So standby ya Mr. Pang nak tanya soalan. Ada berapa soalan? 3 kan?
Ada 3 soalan.
So ada 3. So kita boleh mula dengan soalan yang pertama. So standby ya untuk jawab di ruangan chat ya. Standby ya. Nanti kita akan memilih pemenang yang paling pantas jawab yang tepat. Okay? Okay. Tanya soalan.
First question why system being designed to vary the refrigerant flow? I repeat the question.
Ruangan chat you boleh tengok juga dekat ruangan chat. You tengok. You boleh pilih nanti kita pick.
Mana? Okay.
You tengok yang latest sekali ya.
Okay. Ya. Dia keep lompat lah. Macam mana saya mau tengok yang terawal sekali?
Ya, you tengok ada yang mana ada jawab soalan you lah.
Soalan saya. Okay.
You tengok balik ya.
Saya tengah tengok ni. Okay. Saya tengok. Okay. Ya. Okay. Ya. Okay. Saya nampak satu first question. First answer. Charles Lee dia cakap energy saving. Dia yang paling cepat. I scroll through.
Okay. So the winner is for Charles Lee lah.
Charles Lee. Paling cepat lah.
Okay.
Yang lain
yang
lain answer betul tapi dia lambat sikit.
Lambat sikit. Okay, tahniah kepada congratulations to Charles Lee. Aris nanti boleh contact Mr. Charles Lee tu untuk kita bagi hadiah. Okay. Standby for the second question.
Okay. Second question nanti I scroll through, saya tengok soalan yang jawapan yang betul yang pertama saja.
Tak apa.
Okay. What will be the range of water flow? Kejap sebelum kalau yang dapat punya kasih peluang orang lain Okay. What will be the range of the water flow rate for water cooled VRF system per module and the standard rate flow rate at indoor 27 dry bulb 19 wet bulb.
Soalan susah. Saya pun tak boleh jawab.
Soalan tak ada susah. dalam saya punya slide ada actually.
Oh,
Saya
ada. Okey.
purposely
Apa yang-
highlight sama merah lagi. Merah lagi.
Sudah ada jawapan yang betul tak, Bang?
Ada
Belum
satu
lagi?
saya nampak. Okey, saya punya soalan perlu ada soalan ini ada dua perlu ada dua jawapan. Okey. Saya yang saya nampak ialah satu jawapan saja. Satu jawapan saja. Okay, saya mau cuba tengok yang dua jawapan. Tak ada. Okey, tak ada orang kasih dua
Belum
jawapan.
ada lagi pemenang. Boleh masih jawab lagi. Belum ada pemenang lagi.
Okay.
Boleh jawab lagi.
Sekali lagi saya repeat the soalan. What will be the range of water flow rate for water cool VRF system per module and the standard rate flow at indoor 27, dry bulk 19 wet bulk. Maksud soalan ini ada dua. Soalan ini mengandungi dua soalan.
Perlu ada dua jawapan lah.
Ya, perlu ada dua jawapan. Okey.
Okey, masih belum ada pemenang yang boleh tolong jawab. Boleh dapat hadiah pen special lah. Bernilai saya tak tahu apa harga.
Dia jawab satu soalan tapi betul. Macam mana saya nak kasih itu pen punya cover saja.
It's up to you. It's up to you. Kadang sometimes pun kita ambil yang the lucky one lah.
Lucky one lah. Okey. Saya tengok masih jawab.
Tak apa. Bagi peluang dia orang jawab dulu, Bang. Tengok. Bagi peluang dia orang chance dia orang jawab dulu. Okey, sudah dapat pemenang? Sudah ada?
Tak ada.
Tak ada lagi. Yang hampir tepat lah.
Yang hampir tepat ada satu. Ada satu. Tapi dia left out satu. Dia left out satu lah. Suhairia Muhammad Kasim.
Suhaila Mat Kasim. Suhaila Mat Kasim. Nanti tahniah sebagai pemenang kedua. Mr. Pang sudah pilih Puan Suhaila Mat Kasim. Nanti boleh Haris boleh tolong PM ataupun tolong PM admin kita untuk kita bagi hadiah yang kedua. Tahniah pada Suhaila Mat Kasim. Jawapan yang betul apa?
Jawapan yang betul actually ialah flow rate range ialah minimum 50 liter per minit ke 150 liter per minit. Tapi rated at 96. Okay.
Okay, itu jawapan ya.
Okay. Lagi satu.
Okay, last question, standby. Last question.
Okay, kejap tengok. Okay. What is the allowable maximum pressure drop at the leeward area compared to the original stage unit discharge pressure?
Cepat jawab. Boleh jawab sekarang. Boleh ulang balik soalan, Mr. Pang.
What is the allowable maximum pressure drop at the leeward area compared to the original stage unit discharge pressure?
Cepat. Siapa yang dah ada yang jawab tu. Jawab dulu. Kita bagi peluang untuk jawab dulu. Jawab.
Okay.
AB Ibrahim 50 Pascal, Yuzwan Zainal 2/3, Konsortium Bumi 24 Pascal, Norain Alang 150 kilo Pascal, Anas Ghazali 65%, Yuzwan Zainal 2/3 from the discharge pressure, Ikram 25 Pascal, Ko Han Seng 35%. Dah sudah ada pemenang ke Bang?
Okey, kejap. I score tu Okey, kejap. Ini siapa itu apa? Yuzwan Zainal 2/3. Yes.
Itu jawapan betul ya?
Yes, 2/3 of the discharge pressure. Yes, at least 2/3.
Okey. Kita dah ada pemenang yang ketiga. Cik Yuzwan Zainal 2/3 from the discharge pressure. Tahniah.
Okay.
Kita beri tepukan kepada pemenang. Okay,
right. Thank you.
Okay, tahniah kepada 3 pemenang. Nanti admin kita tolong PM lah Yuzwan Zainal dari Suhaila Kasim dengan satu lagi yang first tadi tu. Admin kita minta bantu tolong PM ya diorang ataupun tolong kontak kita kalau tak dapat dah minta tolong kontak kita. Kita akan bagi hadiah tu sama ada by hand ataupun post. Okay, sebelum kita berakhir kita minta kalau ada yang nak bertanya soalan tadi saya tengok dah terlepas panjang dah lepas ke atas. So boleh ulang balik soalan dalam ruangan chat ni mungkin Mr. Pang boleh jawab sebelum kita berakhir So siapa nak bertanya soalan berkenaan dengan VRV system semua boleh tanya sekarang di ruangan chat Okay. Okay, ada question tu from Anas Ghazali, Mr. Pang. How about the prevention for pest from coming to PCB board?
Apa tu?
Ada punya soalan kalau tengok dalam ruangan chat tu yang the last comment tu dia ada tanya ruangan chat tu how about the prevention for pest control masuk dalam PC board tu ada pest ada
we are facing this actually certain job site especially pest control actually we really need to especially tikus you really need to do a pest control actually regularly selain dari itu especially those outdoor unit nampak lubang semua itu kasih seal with the netting ke apa ke itu yang penting basically you don't give a chance to let the rats coming into your place especially this tikus memang cerewet 3 phase dia boleh gigit putus dia tak mati betul it's not joke is true actually the yellow cable dia putus dia tak mati. So this is actually the facts yang berlaku
Abi Ibrahim mention your sensor tikus suka makan dia cakap sensor tikus suka makan.
Kalau you have a pest control basically I nampak ini isu datang dari mana. Actually ini berlarutan actually ada beberapa job site I dah observe. Actually isu ini start dari bila construction site. Bila construction site, actually you punya makanan tak habis, you campak sini, campak sana, itu startlah pembiakan itu tempat untuk tikus. Mula-mula semua bersih punya, tak ada tikus punya. It start jadi tempat pembiakan. Bila komplek bangunan semua sudah siap, tikus lah actually start jadi control dia punya territory lah. So do it right at the first place. I keep emphasizing do it right at the first place. So if it's keadaan sudah jadi, the only way is you try to use your pest control method. You can seek for your specialist to control. How you control is up to those specialists lah. Macam mana dia control tikus ke apa ke? Harap answer your question.
Miss Syahira binti Khalif dia ada tanya can we get the slide presentation Sebang ada yang nak minta slide presentation
boleh tak ada isu
so nanti mungkin Mr. Pang boleh pass kepada kita akan hantar email lah pada peserta
boleh
Anas Ghazali can you make warranty for the PCB board by animals kalau tikus gigit PC board macam mana tu bukan
PCB board gigit tak ada warranty. Saya tak boleh control tikus
yelah.
Atau tak boleh control animal. Sorry to say that.
Okay. Any other question? Kalau tuan-tuan kalau tak nak tulis dalam ruangan chat, you can directly open your mic, asli direct to Mr. Pang also can now. Kita boleh bagi peluang sekarang. Ada yang nak buka mic kalau tak nak type soalan, boleh buka mic sekarang. Ada ke yang nak buka mic? Boleh buka mic terus tanya je, bagi tahu nama. Ada ke?
Saya punya presentation terlalu susah ke atau terlalu boring ke? Komen jugalah, at least saya ada peluang untuk improvement. Any comment is actually good for me.
Betul. So, any other question cepat? Kita sudah nak berakhir, kita sudah lebih masa ni, sudah 12.30. Ada lagi Okay, so mungkin dah tak ada lah. Ni Mr. Raja Azim ada tanya soalan. Upcoming training by Mitsubishi, how to join? Ada lagi ke?
How to join? Apa maksud?
Kalau you ada buat training apa-apa, macam mana dia nak join lah. Let's say you ada buat installation training ke apa ke.
There's no issue.
So boleh contact direct you lah.
Apa-apa training. Kalau ada upcoming training, yes, boleh. There's no issue. We can together. Kalau Prihoda rela jemput lagi, then I boleh lagi. No issue.
So maybe kalau siapa-siapa mau nak dapatkan training ke, nak dapatkan detail berkenaan katalog VRF ataupun ada masalah warranty, boleh contact tadi ya, Mr. Pang sudah share contact number. Tadi boleh share balik Mr. Pang, you punya phone number tadi kan.
Okay, boleh kejap. This is actually
Kalau
my number.
ada apa-apa ke ini ini boleh direct terus kepada Mr. Pang boleh sama ada email or pergi pada dia punya office number or handphone number lah. Okay.
Yes.
So harap kita daripada penghujung rancangan, moga banyak information daripada Mr. Pang share tadi macam-macam. Kita tengok calculation dia ada punya how to install, do it right at the first time. So banyak juga. So saya nampak, saya faham Mr. Pang pun, kita daripada supplier ni kita memerlukan kerjasama yang baik daripada kontraktor untuk pasang dengan betul Mr. Pang kan. Supaya betul. Sistem tak ada masalah. Macam kita di Prihoda pun sama, kita memerlukan credibility, accountability pada kontraktor untuk pasang betul-betul supaya jangan ada masalah, bukan pada owner, juga pada kontraktor untuk tidak ada kerugian kos pada masa akan datang lah kalau ada sistem ada problem sama kan. Kalau ada bocor semua kan, nanti pun kadang belum masuk dalam defect warranty lagi pun nak kena tukar barang. So cost dia nanti dia akan merugikan kontraktor lah.
Merugikan semua pihak actually.
Betul.
Hello. Mas Lan. Saya mau tanya Mr. Pang. Regarding tadi itu yang itu cool joint. I got search in the internet, but I cannot get the real name. What's the real name for the tools?
Oh, okay. These tools. Give me a minute. This tool is this is a brand, Rothenberg, ROTHENVERGER, Rothenberg. Yes, you can contact us also. We got no issue. Actually, in fact, we have tried out this actually 3 years back. One of the job site, and this is actually our experiment. After 3 years, that's why we decided to share. After we test it out, or else I wouldn't just simply test out actually on this. We wouldn't share out with this. And we already tried one of the job site, and this is one of the consultant's office also. He helped us to monitor any leakage or not. Actually, so far 3 years already. So far so good.
Okay, thank you, Mr. Pang.
Okay, thank you.
Okay, any other question? Cepat, kita masih lagi ada Mr. Pang on the floor. Tak tahu lagi bila kita mau jemput dia. Cepat. Dia sudah lama dalam bidang VRB ni. Nak tanya apa tanya soalan yang susah sikit. Ada lagi ke yang nak buka mic? Okay, so saya rasa mungkin dah tak ada Mr. Pang. Mungkin kita dah lebih masa pun.
Okay, thank you. Okay. Thank you for all of your feedback. Any weak point, please comment also. I'm trying to improve on that. Okay. So any other question would like to ask? Or else you can also just email me. There's no issue. Okay. Hello, Maslan.
Hello, Mr. Pang.
Yeah, Maslan. Yeah, yes.
Ada nak tanya itu O-ring lifespan.
Oh, O-ring lifespan. Okay, in fact, actually, kalau you tengok, this is actually the history. They have been actually using in Germany about 15 years ago. Actually, this technology, O-ring lifespan, actually manufacturer ini claim boleh about 25 years old, 25 years.
Okay.
Dia punya O-ring, special O-ring, saya pun tak tahu apa material dia punya. Itu
Right, thank you.
Okay. Yes. Any other?
Ada lagi ke? Tadi line saya, internet saya pula ada masalah tadi. Saya keluar. Okay. Okay, ada lagi soalan ke? Ada lagi? So kalau tak ada soalan, kita mengucapkan ribuan terima kasih kepada semua, kepada penceramah kita hari ini, Mr. Pang. Banyak information kita dapat pada hari ini. Okey, terima kasih semua.
Thank you
So
very
kita
much.
jumpa lagi pada siaran yang akan datang. Terima kasih kena tunggu sampai habis dan tahniah juga kepada yang pemenang dapat hadiah pen eksklusif tadi tu daripada IMZ tadi. Okey, jumpa lagi pada masa yang akan datang. Okey. Okay, stay tune pada Prihoda punya kita punya website dengan Facebook, kita ada banyak information. YouTube pun kita ada keluarkan konten. Time to time kita akan invite pada speaker lah. So kalau tuan-tuan ada speaker-speaker yang baik, boleh bagi cadangan kat kita akan jemput expert-expert dalam bidang hatchback ni untuk kita bersama berkongsi ilmu bersama-sama kita membawa negara kita kepada ke arah yang lebih baik Kita nak make sure installation quality kita punya bidang hatchback ni tak banyak membazirkan aircon sebab 60% daripada bangunan tu adalah daripada aircon. Kita kena jimat banyak kita jangan bazir. Okey, itu saja daripada Prihoda Malaysia. Kita ucapkan ribuan terima kasih. Jumpa lagi. Assalamualaikum. Bye bye. Jumpa lagi. Okay bang, thank you bang.
Waalaikumsalam. Thank you, boss.
Thank you.
Alright, bye-bye.
Record